Good afternoon, everybody, and welcome to this STEG workshop for Theme 0, which is about data and conceptual measurements. Welcome to all attendants. Welcome to all presenters. We're looking forward to a very exciting afternoon with some great papers related to the theme of this project and so develop structural change in developing countries, in particular in sub-Saharan Africa. I'm welcoming you on behalf of Akos Valentini, who is also in here, and we decided to share the chairing duties, and he'll take over in some time. But the first part is on my is for me. In terms of setup, we have 40 minutes for each of the papers, so I'll ask presenters to please keep to about 30 minutes to allow a sufficient time for questions. If you have questions, especially the more substantive ones, you can leave them in the chat during the talk. And after the presentation, we'll also collect some questions from participants before getting the authors to respond. So unless there are urgent logistical issues people want to clarify, I suggest we move on to our first speaker, and also one of the recipients of a small research grant from this project, Tilmann Von Carnap. Tilmann, the floor is yours.
Thank you very much, Robert, and thanks everyone for joining. And of course, also thank you very much to STEG for funding this research in the first place. I'll be presenting a new tool that uses satellite imagery to derive indicators of economic activity in real time in developing countries. This project's motivated by that monitoring economic developments and understanding the effects of policies typically needs localized and frequent data that aligns with the time period at which these projects are implemented. At the same time, while a majority of the world's poor live in conditions and base their livelihoods on sectors that are very hard to monitor. So in agriculture in particular, it happens over space in a dispersed fashion, and this agriculture, as well as the businesses that people use to support their livelihoods, are informal and therefore not covered in public systems much. These two factors lead to that data collection at scale is costly and sometimes even prohibitively costly. As a result, we have fairly few high-frequency economic data panels over large areas, and that limits the questions we can ask. While these data often have great detail, the scale, the geographical scale at which they're collected, or the interval that they cover may not align with many of the questions we're interested in. And that's particularly the case in remote or conflict-affected areas where a lot of where poverty looks to become more entrenched and looks to be persistent. So in this paper, I use daily satellite imagery to develop and test a methodology that monitors activity in these areas, particularly in rural markets. And this methodology is going to be applicable across large geographies. So what are those rural markets that I'm interested in? The sort of picture I want you to have in mind is on the bottom left here, a market in Ethiopia where each Saturday people come together, put up these stalls made of plastic tarps, some wooden structures, and display the goods they have for sale, both for itinerant traders that may come from larger cities and for local populations that sell their agricultural goods or small manufacturers. These markets are a persistent and global manifestation of this exact phenomenon of small-scale informal trade. They are well documented throughout human history, and they remain relevant until today. We know from LSMS surveys that, again, in the case of Ethiopia, people, at least for legumes and vegetables, sell a high share of of their products at markets, and indeed sell, conditional on selling most of those sales take place at markets. Furthermore, a substantial share of these important household enterprises are operated at markets, where across 3 countries in East Africa here, the majority of enterprises are engaged in retail, but a substantial part is also in these sort of industries or small-scale services that make use of the large numbers of people that come together at these markets. And while we may think that because of improving transport infrastructure and improving telecommunications, markets are sort of an institution of the past, I find as a preview here that market activity in East Africa has actually been growing at substantial rates prior to the pandemic, suggesting that this phenomenon is not likely to disappear anytime soon. So what does understanding what's happening in these markets add to the tools we already have? There are, as I would classify them, 3 main sources for sort of not macro level, but at the level of small geographical units, such as households or firms, 3 such main data sources. First are household surveys that we may all be, or that we're probably all familiar with, administrative sources such as tax records or tariff data, and proprietary data like bank records or call detail records that researchers have used. Relative to household surveys, which of course collect a great amount of detail, using satellite imagery to monitor markets allows us much more frequent observations, and indeed to continue to collect those observations when implementing household surveys is unfeasible, such as during times of conflict or more recently during the pandemic. Relative to administrative data, using satellite imagery has the main advantage of being able to observe informal and the rural economy, which, as I said, is otherwise hard to monitor. And for proprietary data, perhaps obviously, it's inherently difficult to get access to this data. And it requires sort of long-term collaboration with these partners, which makes it hard to transfer them across contexts or scale them over time. This paper is, of course, not the first to use remote sensing for economic indicators. There's a big literature using nightlights to monitor economic development overall, and more recent literature that uses machine learning on high-resolution images to predict local levels of wealth and poverty. Relative to the nightlight data, there's again an advantage of frequency here, and a more obvious one, since I'll be using daytime imagery, this approach can shed light on places that are not electrified as you would need for nightlights. Regarding this approach using machine learning to predict local wealth levels, what I'm going to look at is going to be much more about flows than about those stocks accumulated in wealth that's visible in this imagery that they use. And as a result, the method that I'm going to present is likely going to be more able to pick up adjustments, short-term adjustments in income, especially downward ones that we may be interested in as well. So here's an outline for the rest of the talk. I'll start with a sort of obvious question. If we want to study what happens in markets, we first need to know where they are. And since few governments publish sort of detailed maps of where and when markets happen, the approach I developed first looks for these markets before then, in the second section of the paper, tracking their activity. I'll close with three sections on insights that this data has already unveiled, but I think there's a lot more to be learned from this data source. So let me start with how I find those markets. I'll explain the basic idea by way of an example here, where we see a place in Kenya in 2 pictures. On the left, a high-resolution image from the Google Earth archive that's been taken on Friday, and on the right, an image taken on Thursday. If you look closely and compare these 2 images, you will see that on the left here are these structures on the village square that are sort of that are the same tarps and vehicles that we've seen in the ground picture before. So comparing these 2 images, the market stands out as relatively bright. So in principle, we could just tell a computer or tell somebody to zoom around Google Maps and look for places that look like these markets, and we would be able to map them. The problem is, though, that imagery at this resolution is typically only captured at most a few times per year and may not show market days for the place where that it captures. So to still make progress, I use a different kind of imagery, which is taken every day, and scan this imagery for periodic changes. So changes in the imagery that happen at a regular frequency, in this case, at a weekly frequency. This imagery is, an example of this imagery is here. It comes from a provider called Planet. This image shows the same place that we saw before, just slightly more zoomed out. Just for your reference, I hope you can see my cursor. The place we saw before is in the upper middle of this image. You can see that this image has a lower resolution, but it's been taken, or it's taken every day, clouds permitting. And as I scroll through these images, you can see that there's a couple of things changing. There's clouds floating by, or fields being harvested, or sometimes there are clouds casting shadows. But there's still, when you compare these two images here and focus on where I place the cursor, you see this bright patch popping up, which is not just the cloud. And so again, what I'm going to do is to look at through a large stack of these images for changes in brightness that occur at a regular frequency. So if I want to look at changes in brightness, I need something to make this change relative to. And the idea to compare that markets are relatively bright to non-markets means that I need a picture of a non-market day. The problem is, however, that I ex ante don't know when markets are held where, so I cannot use any sort of auxiliary information for that. Instead, I make use of the fact that markets in the context that I'm interested in typically take place on less than 4 days of the week, or usually on 1 or 2. So if we take a large stack of images and collapse them to what's called a median composite, so you can think of this as taking the average of, or taking the median of all those images, then that image is going to look like a typical day. And a typical day in places where markets are held less than 4 days a week is a non-market day. So then I can go ahead and compare each individual image to this reference image, giving me these differences in brightness here, where green pixels here are relatively bright compared to the reference image, and red pixels are relatively dark. There's still quite a lot of noise in this from the image conditions, from the varying image conditions that we saw before. So a key step is to discretize these continuous changes in brightness here into a sort of a dummy representation of pixel exceeding a certain brightness threshold or not. I do this with this parameter alpha here that I'll come back to in a second, how I calibrate it. This is just to say what constitutes a brightness change that I want to consider. Second step is then to say, okay, I have all these brightnesses across different days. Now I'm going to look at on which days of the week do they happen in a systematic way. So when I collapse these stacks of differences by day of the week, I see that, for example, on Thursdays, in this case, there's sort of no clear pattern coming out. But on Fridays, there's this bright patch here where on a high share of Fridays in the sample, we saw this relative brightness change. And then with another parameter that I just call beta, so what's the share of Fridays, let's say, in the sample on which I detect a frequent change, I can extract this market area, which aligns, in this case, luckily well with where we saw the market structures before. So then, to summarize, this approach gives me two outputs. The first is basically a shapefile of contiguous areas that are frequently bright. That's my measure of market areas and the days at which they operate. And the second is from each image, I can calculate a summary measure of those brightness deviations, which is going to be my measure of market activity. I'll get back to that in a second, how I construct it and how I interpret it. So of course, we would like to know how good this approach is at finding markets. And the two questions I ask here is whether the method detects markets or something else, and whether the method detects markets in places where they actually exist. Regarding the first question, An obvious confounder could be if this method picks up other things that happen at a weekly interval, for example, religious gatherings. Here I validate with geolocated mosques and churches in the OpenStreetMap that I never detect those, suggesting that these meetings are held at different times than when the satellite flies by, or just typically not under open air. And indeed, the patterns I detect are usually in village squares or along roads, so in places where we would markets expect to take place. The second question, whether I have sort of a high true positive rate, detecting markets where they exist, I use one of the few existing data sets on weekly markets, which comes from a study by Bergquist and Dinerstein in Western Kenya, where I'm going to say that, and which I'm going to use to calibrate the parameters of the method. I'm here going to claim success if for a given market in this validation data set, I detect at least a subset of the known market days, but no other day of the week. So here's a map of these validation markets in Western Kenya, about 60 of them. And on the right, you see a summary of this calibration exercise, also indicating the accuracy the method achieves. On the horizontal axis, you have a range of parameter values for this parameter alpha, which is what constitutes a brightness change. And on the vertical axis, you have a range of parameters for what constitutes a frequent brightness change. The colors indicate for each of those parameter combinations, what's the detection accuracy, what's the share of markets that I accurately detect, according to the metric I showed before. So here I find that there's this relatively broad intermediate range of parameter values where I detect 85% of markets, which is going to be the accuracy that I work with going forward. So after having established that the method indeed finds markets, what I did for the last few months is basically to apply it to a large set of candidate locations focusing on East Africa. And so I basically went around the map, identified places that might have a market based on the way they looked in high resolution imagery, or just based on where roads are and based on where towns are. And so that's all of these dots. In the orange places, I looked for a market but didn't find one, probably because there are no markets there. And in green are places where I looked for a market and indeed found one. So that's just to give an idea of that this is possible to implement at the geographical scale of a country. In terms of how frequent I get data out of this, that's summarized on the right here for Kenya and Ethiopia, where the red lines trace the number of observations for a market day that I get on average for each market within a month. You can see that this data starts in 2016. That's when the satellites were launched. And initially there were relatively few satellites in orbit. Once this increases, I obviously also get more images, so a better chance to get an image, a usable image on a market day. In Ethiopia, there's some seasonality in this, just because the weather patterns are there such that during some parts of the year, it's cloudy and markets are not visible. But overall, in Ethiopia and Kenya, you can get between 2 and 5 observations per market per month. Okay, so now that we know where markets are, let's talk about what we can actually measure at them. As I've said before, I basically summarize these brightness deviations within the detected parameter as a measure for how many people are at this market, where the basic idea is that, okay, we have detected this market area, and some days the market will be more busy, then it should be more bright. On other days, it should maybe less busy, so then we see more of the bare ground sticking through, which is less bright in the imagery. I want to interpret this as a high frequency measure of changes in local GDP or local production, where the idea is that if I go to a market, then I either have money to buy something or I have something to sell. So I have produced something and already got money for it, or I have produced something and want to sell it. And a day at which more people come to the market must be a day where more such production has taken place. Importantly, though, I want to interpret this as a measure of flows or changes, and not as the nightlight literature does, as a measure of stocks or wealth, precisely because it's not, of course, the case that a place that has a market is necessarily richer than a place that doesn't have a market, just because markets have a spatial structure. But again, a day at which the market is busier must be a day where more money changes hands, where more money has, or where more value has been created, than on a day where the market is less busy. A summary of how this data looks for Kenya is on the right here. Let's first focus on the colorful lines. They trace this measure of market activity on average across the around 450 markets in the sample per year. You can see, first of all, that if you look at the lines for 2017, 18, and 19, there has been this sort of steady upward shift in levels of market activity, suggesting indeed that markets have been growing. This changed in 2020 when market activity dropped drastically during the pandemic. And I'll have a little bit more to say about that. And more recently in 2022, until a few weeks ago, the market activity has been relatively low compared to previous years as well. In terms of interpreting magnitudes here, it's not super straightforward to think of how a certain level of market activity translates into like a more easily interpretable number in terms of dollars or whatever currency. But as a reference, we can use this dashed line down here, which is a summary measure of those same brightness deviations, but taken on non-market days, where the satellite also flies by, but there's no market happening. So those are the days where not necessarily no activity takes place at those markets, but substantially less. So that's a bit of the lower end of the spectrum. And the upper end of the spectrum, you could say, is, for example, during the later part of the year here of 2019, that's when markets were at their busiest. So that again just reinforces this interpretation of changes rather than levels. If we want to know, of course, we would like to know how well this measure tracks rural production, at what frequency can we use it, at what geographical level. Here I'll have to punt a little bit because it's not straightforward what data source we would use for that. Existing household surveys that may sort of be the first suspect to do so, they typically only have one observation per year, but we know that in this context there's high intra-annual variation in how much people consume or produce. So it's hard to link this data to the market activity data. And furthermore, it's sort of fairly difficult to match households from the sample in the household surveys to the markets that they go to. In future work, I plan to correlate the data I collected here with firm revenues and household expenditures and prices that have been collected as part of a major cash transfer study in Western Kenya over the last 6 years. To still get an idea of sort of what the trade-offs are with this data, I constructed these graphs on the right here that compare for different hypothetical sample sizes how accuracy decreases relative to the full sample size that I use, the complete sample size that I use. In red, you have a line that shows the estimate for the change in market activity between 2018 and 2019, so approximately 0.06 units. And the intervals show what happens to this estimate if I artificially exclude either markets on the right from the sample, or if I exclude images within a market from the sample. So here we can see that if hypothetically I only had half as many images, I would lose less in terms of accuracy than if I only had half of those markets, suggesting that there's also quite a lot of geographical variation in what happens at these markets. So we would like to have broad samples here. Okay, let me use the remainder of my time to talk about 3 insights from remotely sensed market activity. First, looking at its relation to the agricultural cycle. As I've argued before, that this is an indicator particularly useful for rural areas that are linked to the agricultural economy. First insight here is that market activity in Kenya, for example, here is seasonal. So it peaks around harvest time. That's when people have, when labor markets are relatively active, and of course when people are selling their harvests and have more money to spend. And this is reflected in higher attendance of markets. It's also true that that in years where rains have been relatively abundant and therefore presumably the harvest relatively good, at least barring extreme cases, market activity in the following harvest season is relatively higher. So that's what you see in the bottom right graph here, where I relate the standardized measure of rainfall shocks during the growing season with market activity during the following harvest season. And I think what's interesting to note here is that while we are accustomed to the idea that there's sort of large intra-annual variation in these agricultural economies, there seems to be inter-annual variation from rainfall in this case at a similar magnitude reflected in market activity. A second focus that I just want to highlight here is understanding what happened during the pandemic. Of course, that was a time where everyone scrambled for data, and where a particular question was, what would these lockdowns that were implemented across the world do to poor populations and populations in more remote areas? And there were sort of these two different views, that this is a terrible thing for poor people because it cuts off access to markets, or poor people are perhaps not so affected by it because they're farming, they do subsistence farming and they can rely on their own consumption. I'm not going to weigh in on this debate very much. I'm just finding that market activity as a measure of rural activity remained low much longer than other commonly used measures. This you may be familiar with this measure provided by Google that tracks urban mobility, visiting workplaces and the like. That recovered relatively quickly in Kenya and Uganda, but market activity, especially in Uganda, took almost the whole year of 2020 to come back to normal levels. Furthermore, in Kenya, an interesting finding is that in some areas, markets never recovered from, or some markets never recovered from being closed during lockdown. So that's this red line here. You see that market activity was at normal levels up until early 2020 when it dropped and then never recovered. So that begs the question, or that opens up the question, did this market activity just disappear, or was it perhaps replaced to other areas? So what I do is that I look at, I here show a map of markets in Kenya in red, those that declined, and I match each declined market to its nearest two neighbors, and those two neighbors again to their nearest two other markets. And what I find is that while all these groups had relatively similar patterns of market activity before and during the pandemic, afterwards we see this divergence here between the yellow and blue line, where markets that lost their neighbor sort of appear to benefit from that, or appear to pick up some of the activity that happened in those places, whereas slightly more distant markets did not. So this suggests that there has been this process of some markets, for whatever reason, always being used. Then there was this shock, they closed down and people started going somewhere else. Finally, an obvious application of this data is in times of conflict, where again, other sources of data are hard to come by, and for humanitarian reasons, as well as for research reasons, we may want to know what's happening economically on the ground. Here I'm just showing one of the outputs of this project, which has been to look at the situation in Ethiopia with a particular focus on the war in Tigray. So this map shows zones of Ethiopia color-coded by how their activity, how their market activity changed relative to a reference period, either year-on-year growth on the left or month-on-month growth on the right, for all the markets within the respective zones that are indicated with these black dots. What just stands out for whatever time period I look at over the last 1.5 years is that market activity in northern Ethiopia and in the Tigray region in particular was very low, if not completely stopped for a long time. So this is a period where there was actually not a lot of fighting going on, but transport and traffic was severely limited. So markets did not function nearly to their normal levels. What we can see on the right here, that during this particular time, at least, markets in some parts of the region had been picking up again slightly. So from low levels. So this just shows that with this kind of data, we can construct relatively flexible aggregations over time and space to look at questions of interest. Okay, so to conclude, this paper shows that remote sensing, beyond the applications that already exist, can also reveal economic developments in rural regions of low-income countries, where before we have mostly looked at urban regions. It can do so in real time, it can do so at scale, and it can do so independent of ground conditions. And I'm very open to any questions or comments you may have, and thank you very much for your attention.
Thank you, Tilmann, for this interesting work. In terms of discussion, perhaps get started with the first one in the chat by Joe Kowalski, who's wondering whether you may be missing out on daily or permanent markets using your filtering approach.
Right. So it's inherently true that I cannot observe markets that take place, or that I cannot detect markets that with this approach that take place at a daily frequency, or that happen indoors, which are arguably which is the mode for most of trading in sort of more formalized settings. I think the focus of this project is specifically on rural areas where these markets remain prevalent and where we may not have information, or where we just don't have other information on the trading activity. Those permanent markets and daily markets, they are typically more formalized in larger cities, so where the government or whoever is interested in them may have a better grasp of what's happening at them. What one could do, and what I'd be excited to do in the future, is once you know where those daily markets are, if you can just find them on Google Earth or whatever, you can apply the same machinery at them. You can look how crowds change there over time. It's just not the particular focus of what I'm doing so far.
So you could you could in principle detect, once you have your sort of weekly markets, or you could detect if they transition to being a daily market. Yeah, totally. I think that would be interesting, because in some sense those are probably the most important development.
If I may do a bit of self-advertisement, that's my job market paper that you can look forward to reading that.
Yeah, so then another question in the chat by David Gomtian, who's wondering about your detection. Should they all be white? And maybe if the covers change over time, is that going to be a problem? So basically about the robustness of your approach.
Yeah, that's a great point. When I say brightness, I'm simplifying a little bit here. So what I'm actually constructing is the changes across each of the color bands of an image. So an image consists of a red, green, and blue color band. And you're right that some structures may actually look darker in an image than the reference, but then typically in one of the color bands, they still stand out as bright. In principle, if you're in a context where markets are very dark, you could just adjust the machinery to look for absolute deviations and not just brightness deviations. Typically, though, because these markets are held open air, people use bright colors because it just doesn't heat up as much. So I focused for now on these relatively bright deviations.
Yeah. So if I may interpose one question here on my own. So yeah, you talk already a bit about changes in the market patterns. But one of the nice things here is that there can be different margins here, right? So there can be the changing in frequencies of these markets. There can be whether a market occurs there at all or not, and the scope of the market's activity that's there. So do you have some sense of how to how to quantify those different margins and whether that may be helpful.
Yeah, thank you. So limitation of this particular data source is that it only goes back 6 years in time. It started in 2016, so some of those processes may happen relatively slowly. I agree that they are super interesting to understand. And COVID may be one of those shocks that's interesting to trace further, and maybe in other countries. In sort of follow-up research on this, or in companion research, if you want to call it that, I combine this data that I collect today for Kenya with historical market records from the 1970s, where people have basically done the same thing, sending around enumerators and mapping markets. And a very interesting finding there, I think, is that markets have, a lot of markets have disappeared. So markets have, like, where in the past many sort of smaller rural centers used to have their weekly markets, today they tend to concentrate more in sort of medium-sized towns, and may have in turn contributed to the growth of these towns. What's also the case is that about half of the markets that exist today already existed in the 1970s, and most of them still have the same days of operation. So there is this tremendous persistence over time, even though, of course, the environment has drastically changed.
Great, thanks. Another one from the chat by Triaviri Mamvura, basically twofold. First, whether you paid for it. Well, I guess the answer to that will be yes. And the second is on how the characteristics of the satellite impact the analysis.
Yeah, that's a great question as well. So this data is, this imagery that I use is commercially available if you want to use it at a larger scale, but this company offers very generous packages for researchers as well, so that you can use large volumes of this data for free for your research projects. And the reason I chose this particular source is that it combines this high temporal resolution, so being captured every day, with this high spatial resolution, which is something other satellite sources don't have. I think in terms of using the freely available satellite imagery out there, you do run into the problem that it's only collected every 5 days or so, whereas this data is collected every day, and the resolution is just an order of magnitude worse, and that makes it hard to pick up these small, relatively small changes that I'm after. But in general, this comes back to the point that this data is not available throughout history. So it's hard to extend this machinery to earlier satellite missions.
And I guess the second question is probably also on the whether this is one satellite that's doing it, or whether you have to worry about, I guess, differences in gains and other optical issues.
Right. I mean, so it's the fleet that this company has sent up by now consists of about 200 satellites that you can access. There's a lot of pre-processing done by the company itself, so I'm basically just accessing the optical imagery that they provide.
Another question by Frida Mugo, who wants to know if you've looked at the relationship between rainfall and market activity.
Yeah, so I have looked at the sort of more long-term relation between rainfall and market activity, where I do see that sort of the patterns of market activity within a year are seemingly in line with the general weather patterns, so that they relate to the times when that markets are busiest, when things get harvested, and also across years that had good rains had better market activity, had higher market activity. I think that you could look at, I'm not sure if that's what your question is after, you could look at sort of the more short-term impact of how rainfall affects access to markets. If in a certain region it rains the day before the market occurs, is market activity lower than one would have expected the next day, suggesting that there are difficulties in access. That's something I haven't done, but one could look at.
Okay, great. maybe room for one or two more questions, either in the chat or speaking up. I guess it's a pretty disciplined crowd over here. Yeah, Charles Asengo, how do we get quantification of goods, sources, sales, and taxes paid? So I guess a bit on what is the potential scope of moving beyond here's a market and here's when it's operating.
Yeah, so knowing exactly what's being sold on those markets is difficult with the imagery that I have. There's one exception, that it's fairly easy to see cattle markets because they look very different from above. And I think the same would apply to fish markets. So there you could get at kinds of goods that are traded there over time. I think if you're interested in sort of the individual market, it's hard to get at that from space, and you would have to cross-validate that with other on-the-ground data sources.
Great.
Can I ask one question too?
Please.
Sure. Hi, Tilmann. I just for curiosity, that the result that some markets using the new measure experience permanent drops in their activities after the COVID-19. And that seems to be very super interesting. Do you have some potential explanations for this finding?
Right. So I think those might be markets that are, well, since I find in general that markets are disappearing in the long run with this historical data that I mentioned before, and there's this general pattern of market concentration, I think those might be markets that sort of were just hanging on there. Some people used to go there just out of habit, but basically the market next door on the other side of my village already looked more attractive because it was better connected. So it's something I haven't looked at sort of in a very detailed lens yet of how this coordination comes about or so, but I think there's a very interesting thing about the persistence of these markets that people just go to out of habit, but perhaps they remain stuck in inefficient patterns there.
Yeah, I thought it was very interesting because it I was thinking of some coordination failure about deforming the market, but it's super interesting finding. Thank you.
Yeah, so I suggest we close the discussion here. Tilmann, there's one follow-up by Charles in the chat. Maybe you can answer him in the chat as well. But given time, I also want to move on to our second presentation by Jaedo Choi, who is going to talk about technology adoption and late industrialization. Same setup. Floor is yours. Should unmute, by the way.
Can you hear me?
Yes.
Okay, thanks Robert and Nicolas for including this paper, and thanks everyone for joining this talk today. So I just started my work at the board 2 days ago, so usual disclaimer applies. Any results or conclusion in this research presented are not my own and do not necessarily represent the views of the Federal Reserve System. But this paper titled Technology Adoption and Late Industrialization, joint work with Younghun and Shim, who is also here, and he can also answer some questions on the chat. So in the poster period, there have been divergent patterns of industrialization across developing countries. Some developing countries, such as South Korea, Taiwan, Turkey, Brazil, successfully transformed their economic base to manufacturing, while many other developing countries remain stagnant. These developing countries achieved their industrialization through the adoption of foreign advanced technology rather than their own innovation. This adoption-driven industrialization is known as late industrialization, and this late industrialization was considered to be different from the earlier process of industrialization in the Western developed economies. So many policymakers and economists have believed that the adoption of foreign advanced technology can make poor countries richer. So the newly adopted technology will first improve productivity or performance of the firm that directly adopted technologies. And also, if knowledge from newly adopted technology can be diffused locally through the knowledge diffusion channel, it's possible that technology adoption can be even more stronger development policy. However, there's a big challenge of the measurement. is very quantitatively, empirically, impact of technology adoption is not well known due to the lack of the data availability. So in this paper, we address the following question. How did technology adoption and local spillover contributed to late industrialization? In particular, we studied South Korea in the 1970s, and South Korea is a good country to study this kind of question because South Korea is known for very rapid, successful transformation to industrialization. And also during this time period, South Korea conducted a policy which provided some temporary adoption subsidies for the heavy manufacturing sectors. As long as there is a positive externality, such as local productivity spillover exists, and it's possible that this type of policy to be welfare improved. So in this paper, Younghun and I, we hand collected a novel history data set. This data set covers the universe of firm-level technology adoption contract between South Korean and foreign firms. We also digitize firms' balance sheet variable, so we can match firms' balance sheet variable to these firms' adoption activities. We also have detailed information on firms' geographic information. The key advantage of this data set is that we can measure firm-level technology adoption directly at the detailed micro level. So most of the adopted technology during this time were know-how on how to operate machines or how to set up some factory or capital equipment related to the adopted technologies. This is one example from this is one example of the technology adoption contract between South Korea and Japanese firm at that time. So as a part of the contract, Japanese firm had to provide some blueprints to the Korean firms. And second, as a part of the contract, Japanese firm had to provide training services to Korean engineers by sending its skilled workers. Third, they also have to provide Korean engineers the opportunity to come to visit the Japanese factory and let them see how they were actually operating this kind of machineries on factories related to the adopted technology. So technology adoption in this paper is going to be mostly about the adoption of the blueprint or the training service provided by the foreign firms. So using this new data set, we provide three empirical facts. First, technology adoption improved direct productivity gains to adopting firms. To deal with selection issues, we're going to compare adopting firms and non-adopting firms that tried to adopt but failed for some exogenous reason. And I'm going to talk about this identification a little bit later in the future. But empirical estimate implies that adoption increased adopting firm sales and revenue TFP by 45 to 50%. We also provide local productive spillover effect. To do so, we use spatial variation at the very fine level geographic details. So our empirical estimate implies that one standard deviation increase of the spillover measure were associated with the positive increase about the 12 to 15% of firm sales and revenue TFP. And third fact we provide is that complementarity in firms' adoption decision. We use the same variation with local productivity spillovers. Our empirical estimate implies that one standard deviation of the spillover measure increased firms' probability of making a new adoption contract by 1.5 percentage points. So these three empirical facts suggest a dynamic spatial model with firms' technology adoption decision and local political spillovers. And we're going to assume that spillover operate with one-time lag so that it can generate dynamic complementarity in firms' adoption decision related to our third empirical fact. And because of dynamic complementarity, the model potentially features multiple steady state. When multiple steady state exists, it's possible that one-time temporary adoption subsidy can have permanent effect on the economy because it can move an economy to a new transition path to a alternative or better, more productive, more industrialized steady state. And we use this model to conduct the counterfactual. So what if the Korean government had not provided temporary adoption subsidies? Because of the multiple steady state, we obtained some large quantitative results. The model is going to be calibrated to the microdata and the econometric estimate. Our results shows that if there are no adoption subsidies, Korean economy could have converted to a less industrialized steady state where the heavy manufacturing sector GDP share is about the 15 percentage point permanently lower, and heavy manufacturing sector export share would have been 20 percentage point lower. And especially this heavy manufacturing sector GDP shares 15 percentage point drop is equivalent to moving the 2000 in Korea level to the 2000 in Mexico level. Now let me talk about the data more in detail. So our construct defined data set is firm level unbalanced panel data. The key variable here is going to be firm's adoption dummy variable, which is the dominant variable of South Korean firms' adoption status. We also have the digitized firms balance sheet variable, which include typical balance sheet variables such as sales, employment, asset, and fixed assets. We also have detailed information on firms' location of production. Our sample period covers 97 to 1982 with 10 manufacturing sector, and 4 of them will be classified as heavy manufacturing sector. We covered the, as we emphasized before, we covered the universe of South Korean firms' technology adoption activities, and the balance variable is also represented at the national level. As far as you know, this is one of the first data set that utilizes from-the-panel data to study South Korea's rapid industrialization or growth, economic miracle growth period. So technology, so most of them are about know-how, the transfer blueprints or the training service provided foreign firms. And there are about 1,700 contracts made by about 700 unique firms. And most of the adoption activities happen within the heavy manufacturing sectors. And the digitized and hand collected from the contract document that was submitted to the government authorities. And we also digitized firms' balance sheet variables as well. Okay, before going to the empirical analysis, let me show you some South Korea's industrialization patterns using the aggregate level data. So this is the South Korea's heavy manufacturing GDP share between 1997 and 1982. So during this same time, heavy manufacturing sector GDP share increased from 6 to 14%. To give you an idea how rapid this transformation was, in the early 1970s, it was about 6%, which is about Greece level. In the mid-1970s, it was reached 9% about the Mexico level. In the early 1980s, it reaches 14%, which is above the United States level at the time. And our global micro data set reveals that this rapid changes in heavy manufacturing sector GDP share was accompanied by the rapid increases in the amounts of technology adoption made by South Korean heavy manufacturing firms. So this graph is the number of new foreign technology adoption contracts made by South Korean heavy manufacturing sector firms. And as you can see, during the same period, the total amount of technology adoption each year increased more than 4 times. And this sudden rapid increase in heavy manufacturing GDP share or the amount of technology adoption were not a coincidence, but was rather a deliberate outcome of the government policy, which provided temporary adoption subsidies to the heavy manufacturing sector firms. For the time reason, I'm not going to talk about too much about the details about this policy, but during this time, South Korea implemented nationwide level industry policy, and one of the key aspects of the policy was to promote firms to adopt technology from the foreign advanced economies. Okay, now let me move on to some empirical fact that I find using this new data set. The first is direct gains to adopting firms. So when you're trying to understand direct gains for the adopting firms, one of the key econometric challenge is that firms make adoption decisions endogenously. So because of the selection bias, if you compare non-adopting firms to adopting firms naively, then some unobservable factors may bias our estimate. So ideal empirical scenario to understand this effect would be some random assignment of the firm's adoption status. But the observational data, this kind of random assignment is not feasible. So to approximate such a random assignment scenario, we're going to use winners versus losers research design. So winner is going to be defined as a adopting firm, which is a treated group, and the loser is a control group, which is defined as follows: a non-adopting firm that tried to adopt technology but failed in the end due to some exogenous cancellation made by foreign firms. But we use 2 definitions to define these losers. First, losers should make a contract, and this contract should be approved by the government. Second, however, they couldn't adopt technology at the end because foreign firms canceled this contract for some reasons that seems to be seemingly unrelated to South Korean firms. For example, changes of foreign firms' management team or foreign firms out in bankruptcy. So we are going to, after this classification of losers, winners. So for each loser, we're going to match a winner first by exactly matching a sector and region so that those losers and winners are subject to the same sector and region so that we can observe about some common sector region effect. And then we distance match on firms based on the observable so that we can compare the firms with similar firm size. This procedure gives us like 34 pairs of losers and winners. So key identifying assumption here is that a loser forms a valid counterfactual for a matched winner. And to do so, there are two key identifying assumptions here. First, the cancellation should be exogenous to losers, conditional on the controls. Second, winners and losers are ex ante similar in terms of the both observables and unobservables. So using the balance test, we can show that actually losers and winners were very similar before the adoption using the observable variables. And also because we are controlling this selection effect, but we also assume that these losers were also ex ante similar in terms of unobservables. So using these pairs, we're going to run the following event study specification. So this is the firm's dependent variable for firm I for pair P time T. And we are going to control firm's pair common event time dummies. And our key interest is going to be this coefficient, which is going to be identified by the interaction term between event time dummies and firm's actual adoption status. So this dummy variable takes only value of 1 only for the winner group. We control firm, pair, and time fixed effect. And as dependent variable is going to be log sales, revenue TFP. Our sample is matches 34 pairs of winners and losers. So there are 68 firms in this sample. And key identifying variation is going to be differences within each pair at the event time toggle. So we are comparing only winners and losers within the same pair. We're going to cluster at the both pair and firm level. But this is our one of the first empirical fact that technology adoption increased winners sales by 50% and revenue by about 45%. And this here x-axis is the relative time when the actual adoption happened. So both losers and winners made the contract at the time 0. So and each dot here represent a coefficient estimated for the interaction term. So what this graph says is that before this actual adoption happened, winners and losers were very ex ante similar. However, winners sales increased by 15% after the adoption actually happened. We also find a similar result for the revenue TLP. Okay, that was our first fact, the direct gains to adopting firms. Our second fact is spillover effect. First, we're going to construct a spillover measure for firm I. So for firm I in region and sector J in time T, so we are going to lag spillover measure by H because spillover takes some time to be in practice. And we're going to define the spillover measure for firm I as a weighted average of local firms' adoption status, where the weight is given by the inverse of the distance between two firms. And we're going to, when constructing this measure, we're going to exclude firm I to rule out mechanical correlation. So within the same region or same sector, depending on where you're located, this measure varies across firms within the same region and sectors. So if firm I is located closer to other adopting firms, this measure takes higher values. And if the firm I is located farther away from the other local adopter, this measure takes lower values. And then we're going to run the spillover regression like this. We're going to utilize overlapping long difference between 97 to 97.9, 97 to 90.80. And the dependent variable is going to be log sales or sometimes TFP measure. And we run this changes from sales TFP measure on the spillover here, changes in the spillover. And importantly, we're going to control this region sector time fixed effect. So we are only using the variation within of this spillover measure across the firms within the same region and sector. We're going to control additional controls, and this is an error term here. We're going to estimate this regression model only for the never adopted samples, so non-adopting firms between this sample period. We're going to Choi cluster at the both region and conglomerate levels. And there are some key issues when you're trying to understand the spillover effect. The first is spatially correlated shock. So as long as there's some unobservable at the common region sector level, then the spillover measure, so this estimated beta S will capture the spurious correlation rather than the true effect of this spillover measure. To deal with this spatially correlated shock, we are going to utilize spatial variation at the very fine level geographic details. So the median size of our spatial unit of analysis is going to be about Manhattan size, about 34 square miles or 90 square kilometers. And because we're controlling this very granular level of fixed effect, we only use this variation in distance to adopting firms of the same sector within narrowly defined regions. Another issue might be there can be some other effects of being close to big-sized firms, but rather than this knowledge diffusion channel, which will lead to some typical omitted variable bias. To deal with that problem, I'm going to additionally control two main controls. The first is weighted average of sales, which can potentially proxy for some other agglomeration effect. The second is the market size effect due to local input sourcing. I construct this market size measure using the input-output coefficient and local firm sales and the distance. So the key identifying assumption here is that distance to adopters are uncorrelated with non-adopter unobservables, conditional, and this fixed effect. So this is our main result. Across different specification, we find highly positive and highly statistically significant coefficients. And in the first specification, we do not have any additional controls. In the second specification, we control the weighted average of sales. In the third column, we control the market access measure. In the fourth column, we control for the conglomeration fixed effect. In the last column, we control all these additional controls all together. But the estimated coefficient or stable, and in terms of magnitude, they're very similar across different specifications. So interpretation is that one standard deviation increase in the spillover measure was associated with the local firm sales increase by about the 15%. And this resulted robust to revenue TFP for using the both adopting firms as well. Also, we did not find the large cross-sector spillover effect. And also this spillover regression was also robust to different definition of the spatial unit. Okay, this was our second fact, local productive spillover. The final regression we are going to run is going to be this specification. In this specification, we show empirical evidence on complementarity in firms' adoption decisions. In other words, if more local firms adopt technology, then I'll be more likely to adopt technology today. The dependent variable is going to be firms' new contract adoption stages, and we are going to run the same regression with the spillover measure. We are estimating this using this full sample and also cluster at the region and conglomerate levels. So what we find here is that we also find very positive and highly statistically significant coefficient here. So which means that firms are more likely to adopt new technology once local firms around me also adopt the technologies. So the economic magnitude is as follows. So one standard deviation increase in the spillover measure were associated increase in probability of making a new contract by 1.5 percentage point. And our data says that annual average shares of firms making a new technology adoption contract was about 3%. So this 1.5 percentage point is comparable to the aggregate annual shares which is about like 3%. So far, I have provided three facts. The first, direct effect to the adopting firms. Second, local productive spillovers. Third, dynamic complementarity in firms' adoption decision. So I'm going to build a model based on this three facts. I will explain in a very simple way. The setup is very simple, like closed economies, and time is discrete. There's only one region, one sector for now, and firms are monopolistically competitive. There's a fixed mass of firms, which is normalized to be 1, and firms are heterogeneous along productivity indexed by ZIT. And household supply, labor supply elastically. And because of fixed mass, their income sources is going to be labor income from the wages and the profit rebated from the firms. So in this economy, firms, all the agents make static decisions. So firms make static technology adoption decision. So the trade-off is that the firms can enjoy direct profit gains, but they also have to incur fixed adoption cost, which is in units of final goods. I'll later explain this importance of this assumption and in the later, and also how to make a static consumption decision. For the computational reason, I really simplified firms' that adoption decision in a static way. Even though all agents make a static decision, there's a source of dynamics. The source of dynamic comes from local spillover adoption that were operating with one period lag. So this lag is consistent with my second empirical fact specification, and we treat this externalities. The amounts of adoption in t-1 affect local productivity in time t today. So firm's productivity is composed of the three parts: the direct gain. The first is direct gain, which is parameterized by eta. So if firm adopt technology, it takes higher it has some higher direct gains. The second is spillover, the shares adopt, which is increasing function in the shares of adopters in the previous period. And the third is exhaustive component, which is assumed to follow Pareto distribution. So I'm going to assume the particular spillover functional form here, so that this delta captures the strength of the local productive spillover, and this is interpreted as semi-elasticity. So what I can show is that if I take log of firms adopting firm sales, I can drive the regression specification that was used for my winners versus losers specification, the first empirical fact. So the first empirical fact estimate can be directly connected to my parameter eta in the model. And the second fact is spillover estimate. So I also can drive the spillover specification by taking log of non-adopting firm sales. And one key difference between the specification and my reduced empirical analysis is that in the reduced empirical analysis, I used a variation in distance, but here I assume that firms, there's no distance within the region. So what I'm going to do is that I'm going to assume that in the model, firms are all equally distanced, and then under the assumption, my empirical estimate can be interpreted as a semi-elasticity, and I can map the delta parameter, which governs the strength of local spillover in the model, to the second empirical estimate. So firms adopt technology when only it increases profits. Which means that when only gains from the adoption is larger than the fixed adoption cost. And I'm going to assume that firms adoption cost in the units of final goods, which means that because of this assumption, so if more firms adopt technology in the previous period, it makes today's adoption cost cheaper and therefore generate dynamic complementarity. And when firms' productivity is heterogeneous, firms' adoption decision is characterized by the productive cutoff, and the adoption probability is expressed like this as a function of the cutoff. So theta here is going to be Pareto-shaped this parameter. And what I can show is that I'm going to define lambda t star as a Scholl equilibrium. And because of the fixed adoption cost assumption, lambda t star today increases in previous shares of adopters yesterday, which means that the model can generate dynamic complementarity. And I also can show that given the initial values, there exists unique Scholl equilibrium for each t, which means that there is unique, given the initial value, there exists a unique equilibrium path to each steady state. So depending on which initial condition you have, you can converge a different steady state. Let me explain it graphically. So this is going to be Scholl equilibrium curve. And so this is today's, for example, this point here is going to be today's equilibrium shares of adopters, given the condition on the yesterday's previous shares of adopters. And this curve is increasing because of dynamic complementarity. And because the shares are bounded by 1, this here is also bounded by 1. And steady state condition implies that lambda t should be equal to lambda t minus 1, which means that it should be time invariant. And as long as these two curves intersect at 3 points, there can be potentially multiple steady state. And what I can show is that this, when this in the simplified setting, when this multiple steady state exists, this multiple steady states can be Pareto ranked by lambda star, which is the shares of adopters in the steady state. So this steady state here is what we call industrialized steady state, where all the firms adopt technology and therefore economy has higher productivity. On the other hand, this economy is what we call pre-industrialized steady state, where the only few firms adopt technology and therefore economy has low productivity. And the middle here is the unstable one that is out of our focus. So under this economy, initial condition determines which steady state to be realized. So for example, if the initial conditions given here, economy convert to a pre-industrialized steady state, in any condition given like this, economy convert a better or like higher productivity steady state. So here, our second empirical fact, spillover estimate, spillover plays a very important role. So if there is no spillover, which means that this delta parameter is 0, then economy always has unique steady state. And the Scholler equilibrium curve will be characterized by this horizontal curve here. So let me explain how the temporary subsidy can have very large impact. So suppose economy's initial condition is given this range, which is known as the pure poverty trap in the literature. So even the economist has potential to go to better steady state, because they're stuck in this poverty trap, it converts to a pre-industrial steady state. So one-time subsidy can have very large and permanent effect economy, because it can move an economy from inside the poverty trap to a new transition path to convert to a higher productivity steady state. So I'm going to expand this model to include to the small plane economy, multiple regions and multiple sectors, and also costly trade with the iceberg trade cost and fixed export cost for international trade. And firms are also, I'm going to incorporate roundabout production, and firms also export decisions as well. And also now make consumption decisions, but they also make migration decisions. The reason why I incorporate this migration is that during the industrialization, many economists have found that there's a large increases in rural to urban migration, and also quantitatively, I find large impact of, I find that migration plays as an amplifying factor for the impact of the policy. So the household make the migration decision based on real income, humanity, migration cost, and some preference shock. And subsidy, I'm going to model as input subsidy for adopters funded by the labor tax. It's going to be balanced by the government budget. So I'm not going to talk too much about this calibration, but subsidy we do not observe directly. So we are going to observe the subsidy, common subsidy rate among the adopting firms in 97, 6, 80. What we do is that using the model structure, we can propose identifying moment that pins down the subsidy level, which is about the 11% in our data. And the intuition is that using our empirical findings, eta and delta, it measures benefit from the adoption. The condition of this measured benefit based on our useful empirical findings increases the shares of adopters in the 97, 6, 80 during the policy period can be attributable to the subsidies. Okay, this is our main result. In this x-axis are years, and this here we take directly from our micro data set. So this green line is the data observed. This is the data, and the red here is going to be the baseline economy where the subsidies were provided, and this blue line here is going to be counterfactual economies where there's no subsidies are provided. They all start at the initial point as exactly in the data, and what we show here is that once we also want to assume the subsidy provided temporarily during this gray area, gray zone here. What we find is that if the subsidy had not been provided, South Korea's having manufacturing GDP share, it could happen about 15 percentage point lower in the counterfactual economy. And we find large impact because of the potential multiple steady state in our model. And the second fact is that we also find very similar result for the heavy manufacturing export shares. So if the subsidy had not been provided, South Korea's export share could happen about 20 percentage point decrease. And South Korea's comparative advantage would happen changes substantially. So let me conclude. We find large impact of technology adoption induced by subsidy and late industrialization in South Korea using the novel micro data set. And this technology adoption can explain heavy manufacturing sector GDP share by about 15 percentage point, and it also changes South Korea's comparative advantage. Externalities may explain why amounts of technology adoption in developing countries can be lower than the social optimal level, and appropriate policy that subsidized adoption can be necessary to boost productivity in many developing countries.
All right, thank you so much, Jaedo. This is yet for a very different part of the world, but very, very stimulating work with big impacts. At the moment, I don't yet see questions in the chat, but maybe
I have a question.
I see Joe. Go ahead.
Yeah, sure. So it seems very interesting stuff, Jaedo. I think I saw this also at the NBR, right?
Yeah, similar context, but the different papers.
Oh, okay, sorry. I saw it somewhere then. Okay, anyway. It seems to me like this in your model, the sigma
Yeah,
is really crucial, sort of like how much of the gains that you measure, the sales gains from adopters is coming from the competitors'
yeah,
sales declining and how much is coming from your sales increasing. How big are the cost savings that come, or is it just a small cost saving causing a huge shift in sales? So it's important,
I
like
see.
in terms of the normative evaluation of this stuff and quantitatively. It seems like one thing that you could do is to get at this empirically. I see you're probably doing it some kind of method of moments, but like in an intuitive sense is you get your adopters and you have your matched, your winners and your losers.
Mhm.
But if you only have, I guess, what, 32 pairs or something, 36 pairs or something like that. So maybe you don't have
Yeah,
enough data. But if you could add an interaction about what were in that industry, in that group, what was the total number of adopters, you would have a sense of sort of how much, how big that, how much that depends on the number of adopters. I think that's going to identify sigma
I see.
for you.
Thanks, Joe. For
Just
now, I kind of,
impatient.
no, I think that's a very great point because, for example, because what my reduced from empirical estimate implies the multiplication of the sigma and the parameter of the interest of the model. So if the higher value of sigma implied lower gain from the direct or spillover estimate. So for now, I'm fixing my sigma value to 3, and I'm externally calibrating it. But I think I have to do more robustness checks, for example, taking sigma to value 4 or the other values to quantitatively assess the impact of the
If you imagine there, if almost all the sales comes from the fact that there's a huge elasticity of substitution and a very small cost savings gets me a ton more, a ton more sales, then if everybody adopts, you don't get any of that. All you get is the small cost savings, right?
Yeah.
Whereas if that elasticity is really quite low, then you could be getting a huge cost savings. And so that's why I think the fraction of people adopting is going to sort of identify.
I see.
Because how much your sales changes as you change the fraction of adapting. That's kind of the intuition.
Yeah, no, I think that makes sense. So in our data set, about 10% of the firm became the adopters. And so this is total number of the firms in our data. And this is the about firms that will adopt technology, ever adopt technology. So 7,000, about 700, I think a little bit less than 10%. But
I think a bigger question is how much variation do you have? But can you estimate the thing that I'm talking about? Anyway, I'll quit. I'm sure other people.
Yeah. But what I can do is that, okay. So just let me show you one thing then. So when we use the whole, instead of this like winner loser design, when we run the knife event style specification for all the firms that ever adopt technology, a slight lower magnitude, but we still find very sizable increase in firm sales of revenue TFP. Maybe then for your suggestion, I think when using the shares of the fractions of adopting firms in the industry, maybe I can utilize the whole samples rather than focusing on the winners and losers design. Thanks so much for suggesting that.
Yeah.
Great, thanks. Here's one in the chat. What is the likely progress of the curve if subsidy continued beyond the time where it stopped? So was only a short time frame under which this this policy was in place. Would they've gained more if this had gone on for longer?
So my model, by the construction, as long as there's some spillover, there's always room for the subsidies. But the multiple steady state generate the very persistent permanent effect of the temporary subsidies. So if there's only unique one steady state, then as long as the subsidies are temporarily provided, it's going to temporarily increase its firm's adoption activities, but not permanently. But the dynamic complementary forces generate this potential multiple steady state, and therefore very large impact of the temporary subsidies. And within this model, as long as there's a spillover, there's always room for the subsidies. But the kind of welfare implication of the how to subsidize depending on time or the magnitude is, I think, will be very interesting for the future. Thanks.
All right. Any others wanting to weigh in on this paper? Well, there was indeed quite a bit to digest, so maybe that's still ongoing. I imagine that if people do come up with additional remarks, then the chat is a good place, either directly or in the general one. That puts us a little ahead of schedule for the break, but having a bit more time to grab a coffee or otherwise is probably doesn't hurt. So we continue in 20 minutes. And with the next paper on unequal global convergence, and I'll also pass the chairing to Akos then. Thank you all.
So welcome back, everyone. After the break, I hope you had your strong coffee. I definitely did have a good double espresso to prepare for myself for the second half. And next is Shoumitro Chatterjee on unequal global convergence. Shoumitro, the floor is yours.
Thank you, Akos, and thank you so much for the opportunity. Just making sure, am I audible?
Yes.
Okay, great. And can you see my slides now?
Yes.
Okay, good. All right. So this paper is about sort of spatial inequality within countries. And in this paper, we sort of focus on convergence between regions within a country. But before I get there, I want to start by just outlining what we know about the world and what we don't know. So in terms of what we know, in the last sort of 50 years, several people, including Arvind Subramanian and Justin Sanderfer at the CGD, have documented that there has been tremendous progress in terms of poor countries catching up with rich countries. So there has been overall convergence between countries. Moreover, the rate of convergence between poor and rich countries has increased over time. However, there is very little evidence on what is happening between regions within particular countries. There are some notable exceptions. So there is some work on the US and the UK, which shows that regions within these countries are not converging. But other than that, we know very little. And so in this paper, we are asking kind of two kind of big picture questions. So this enormous growth that we have seen in the world in the last half century, is it really about India catching up with the United States? Or is it just like some regions within India driving all the growth, which are the engines of growth, and those regions are catching up, but other regions within India are kind of falling behind? And in this story, what is the role of structural change, and in particular, structural change from manufacturing towards services? So in terms of convergence, and this is sort of well documented, people have run these growth regressions, regressing, so cross-country regressions of growth in GDP per capita on initial GDP over various horizons. And then the beta that you estimate, if that beta is less than 0, that's evidence of convergence, because poorer countries on an average are growing faster than richer countries, right? So before we dive into the data and look at kind of the macro evidence cross countries on what is happening within, I want to begin with the case study, and the case study is about India. So here on the y-axis, I plot the GDP per capita of India relative to the United States over the last kind of 30 years. And this is kind of the Indian catch-up of the US. In 1980, Indian GDP per capita was just about 4% of the US. And by 2020, it's more than 10%, right? But the big question that we are after is what is happening within India in this catch-up story. So to outline that, what I have done is on the x-axis, so each data point is a state of India. On the x-axis, what we have plotted is the number of years each state has registered a growth of greater than 4%. The 4% number is a little bit arbitrary. We can play around, but the big picture message stays the same. So for the first decade of the 21st century, which is 2000 to 2009, the number of years out of those 10 years for which each of these states registered a growth of greater than 4%. And on the y-axis, it's the same thing. The number of years the states register a growth rate of greater than 4%, but for the following decade, so between 2010 and 2019. And when you plot it that way, what you see is basically all the states kind of cluster into two boxes, the northeastern box and the southwestern box. So there are a bunch of states that had sustained growth in the first decade. So this would be sort of the states in the northeastern corner, like Gujarat, Maharashtra, Tamil Nadu, Karnataka. This is where the big cities of India are. So Bombay, Chennai, Bangalore, and so on. And the other kind of large agricultural states are in the southeastern corner. So Punjab, Uttar Pradesh, Bihar, this is where you see very little sort of manufacturing or services, but a lot of agriculture, right? So essentially in the last 20 years in India, what this picture is showing is that growth has largely been driven by some states, and those states are consistent. They are the ones who have always grown and they continue to grow. Is there a role of structural change here? So these states in the northeastern corner, I call them as sustained growers, and the other states are just other states. If you look at the sectoral composition between the sustained growers and the other states, what you see is the sustained growers have made it not only into manufacturing, so their agricultural shares are much lower than the other states, but also remarkably into services. And this services number is a little bit of an underestimate. So if you notice, for any group of states, the numbers will not add up to one. And that's because in services, we have only considered professional and financial services. In particular, we have left kind of government out. So these states, the sustained growers, have kind of passed their humps. So they went into manufacturing and have now sort of traversed into services. However, the regions that are kind of falling behind, that have not seen growth or sustained growth, are the states where agriculture is kind of still big. And so we wanted to explore this further, whether or not this is kind of just an India story or particular countries, or is it happening just broad-based across the globe? And in that sense, we kind of fall into two big baskets of the literature. So one is just looking at spatial income disparities within countries, and there a lot of work has been done by various authors for the US. So we sort of, the way we kind of increase the frontier of knowledge there is by putting together this evidence for 34 countries that I will show you account for a large fraction of economic activity in the world. And so at a sub-national level, we put together data on sectoral GDP, employment, etc. And the second basket of literature is of structural transformation. And in particular, we are sort of placing the paper in the structural transformation literature, but with sort of space in it. And in particular, we are interested in the the role of structural transformation from manufacturing to services. Why services? It will become clear in a moment, because we think that agglomeration forces kind of play a bigger role in services. So manufacturing is still kind of spread out, but the professional financial services happen in cities, in particular buildings. You need to sort of put everybody together, and that kind of generates these agglomeration spillovers that have particular economic forces that are important for our story. So in order to sort of put together evidence, we started by this sort of not that old paper by Giannone and co-authors, who had already put together data on subnational GDP between 1950 and 2010 on 83 countries. We updated that data set to the most recent year, but in particular, at the subnational level, which are states within countries, we also added data on sectoral compositions of both GDP and employment. Moreover, because we were interested in the evolution, so that data set is not balanced. There are some countries that appear more frequently than others, and other countries are only available for the most recent years. Because we wanted to track evolution, we had to restrict it to the set of countries for which we had at least one observation in each of the decades starting the 1980s. So that kind of left us with 34 countries and 678 subnational regions. The composition of our data set, you can see sort of in the summary table. A bulk of the data set is coming from Europe, but we have the major economies of Asia in it. So India, China, South Korea, so the major growers are there. We have 3 countries in North America. We have 5 countries from South America. The big continent that we are missing is Africa. And to sort of do robustness checks and make sure that kind of the broad story still holds, we will bring in further data on GDP of cities. So that data comes from The Economist, and we do robustness checks using data on nightlife. So overall, we kind of cover about 80% of the world in terms of GDP and 65% of the world in terms of population in this data set. We have to interpolate because we want to track the evolution over time. I won't have the time to get into the details of the interpolation, but it seems that we do a nice job, because once we interpolate data for the subnational regions, whenever it's not available, and we aggregate it up and we match it against actual GDP data for the country that is available from either the World Development Indicators or the Penn World Tables, things line up pretty nicely. Okay, so where do we start here, right? So the first thing we do is run convergence regressions, but now not at the country level, but at the level of states within countries. So we regress the growth rate of GDP per capita over the next 10 years for each state within a country on the initial GDP per capita of that state. And that allows us to compute a convergence rate, which is the beta C here for particular countries, right? So now we will get many beta Cs, one for each country. We compute an average beta C for a time period, which is just a simple average of all the different convergence rates. For each country, and we sort of adjust for the standard errors accordingly. And the result we get is the following. So this is the evolution of convergence rates. So average convergence rate, but now the convergence rate is within countries, between states within particular countries. And as you can see, in the early part of the 1980s, regions within countries were moving closer to each other. So if you think about India, in the early 1980s, poorer states in India were moving closer to the richer states. And that was happening on an average for most countries in the world. Over time, however, that convergence has come to a halt. So if you look in the first decade of the 21st century, we see no evidence of that convergence happening. So poorer sort of regions within countries are kind of staying put where they are, and their position relative to the richer countries are not changing anymore. If you go by if you go and look at it country by country, then compared to the 1980s, post like the global financial crisis, for 19 out of 34 countries, the convergence rate has fallen. And if I look at the share of countries for which the convergence rate has fallen, 56% of the countries that account for 77% of the GDP now no longer see a much lower rate of convergence than was witnessed in the early 1980s. Now we can do robustness of the same type, so we don't have to stick to states. We can run convergence regressions at the level of cities. So we can ask, are cities within countries converging to each other? So is Chennai moving closer to Bombay in India, and so on? This data only becomes available from the mid 2000s. So we can only see the time period between 2004 and 2020. And between cities within countries, again, we don't see any evidence of convergence. So what it points to is basically the growth, the overall convergence between countries that we have seen is probably coming because certain regions and certain cities within these countries are the engines of growth, and there isn't much economic activity happening kind of elsewhere. We can do several robustness checks. We can leave India, China out. We can weight these averages by population of the states and countries. We can look at it sort of by sizes of different countries. The big picture result that in the first half of the 21st century, there has been a stall in convergence is sort of very robust. Now, to look at the role of structural change, the next thing we did is we looked at the relationship between the rate of convergence that we estimated for different countries and development. So in both these graphs, on the x-axis, you either have services employment share or GDP per capita, and on the y-axis we have the rate of convergence in any year for any country. The relationship has been residualized of country fixed effect. So the green line that you see, which is the relationship between the rate of internal convergence and, let's say, services share, is therefore for the average country. And what kind of both the pictures tell us is that as development happened, or as structural transformation happened from manufacturing towards services, the rate of convergence, which was happening early on, that declined, that came to a standstill. And this sort of gives you like the first sort of piece of evidence that this decline in internal convergence between regions within countries has something to do with structural transformation. So one might sort of worry here that with development, there may not be enough inequality left within the world for convergence to happen. So after all, if a lot of development happens and there is kind of initial convergence and sort of inequality falls, there may not be residual inequality left for the gap to close further. So what this sort of chart plots is that. So how does the variation in GDP between regions within a country evolve with structural transformation? And of course, sort of in the initial part of the structural transformation, there's a sharp fall in regional inequality, and then it stabilizes at about 18 or 20%, right? So it's not, so definitely regional inequality has fallen, and that's part of the story, but it's not the case that gaps between regions have closed completely so that there is nothing, left. The second piece of evidence that this agglomeration services story might have some bite, and this is only suggestive, is to look at convergence in skills between regions within countries. So here what we are doing is we are running convergence regressions, but now not on GDP, but on average education. So the question we are asking in the regressions is, are regions where the initial level of education was lower, has the growth in education been faster for those regions within countries? And again, as you can see, early on in the 1980s, regions within countries which had lower education levels, they saw much faster growth in skills, but that process also has sort of come to a halt in sort of the recent years. So this kind of tells you that skills are also getting concentrated in particular regions within countries, and the other regions are not making much of a progress. So we wanted to see if like a standard structural transformation model would sort of explain or rationalize some of these facts. So what we did was something very simple. We took like a canonical structural change model. We put it in a canonical model of spatial equilibrium, and then we simulated the model to see what it would give us, right? So we have the usual sort of so there are three sectors in the economy: agriculture, manufacturing, and services. There's a usual kind of, you have a usual non-homothetic preference with a subsistence level of consumption for agriculture. There will be worker mobility across regions, and the economy will have J regions in space. The only tweak that we will do is we are going to introduce, and I'm going to be more precise about this, is we are going to introduce an agglomeration force in the production function for services. That's it. So this is what the utility function looks like. It's sort of very standard Cobb-Douglas, non-homotheticity introduced via a subsistence level for agriculture. Workers get these idiosyncratic taste shocks that are determined by the usual sort of shape parameter nu. So once workers sort of receive these taste shock, they decide where to locate and consume, basically by maximizing their total utility. So the utility function is very simple. It just depends on consumption of this basket, plus there is a taste to locate in particular, taste shock to locate in particular locations. The production function for manufacturing and agriculture and services is very simple. It just depends. It only uses labor for production, and there is a TFP term. The evolution of TFP we assume in agriculture and manufacturing follows a constant growth rate given by either GA or GM. In services, the only tweak that we do is that the evolution of these productivities will further get enhanced by the presence of agglomeration in services. So if there are more people who are employed in the services sector, they will give a further boost to the productivity of that sector, and delta, the exponent on the labor in that sector, kind of governs the strength of these agglomeration forces. So this is sort of the only non-standard part from like a very canonical structural transformation model and the economic geography model. And as a standard, we assume the growth rate of agriculture is greater than manufacturing than in services. The calibration is sort of still very preliminary. We have tried to sort of target the average country. Most of it is taken from the data, except delta, the agglomeration force, and the subsistence level. So this is basically set to match the share of agriculture in the economy, and delta has been matched to set the share of services in the initial economy. And then what we do is we simulate them. So this is very, very preliminary, but we take like 3 regions in our sort of dummy country. The 3 regions have different initial GDP per capita. We take 2 cases. So the blue case where we have a higher agglomeration force, and the red case where the 3 regions, so there are 3 regions in the country, but the agglomeration force has been completely shut down. And we see how kind of the services sector evolves over time, and how convergence will evolve over time. So we take sort of initial values. The only so there are 3 regions within the country. The only difference between these 2 cases is that in one there is agglomeration, and in the other there is no agglomeration. So in the case that there is agglomeration, you see that one of the regions takes off. So the region with high GDP per capita, many of the workers choose to locate in that sector because there is a feedback from agglomeration in services. So once you start off with a little bit of structural transformation in services, that region starts attracting more workers for the services sector. And on the y-axis, we have the share of workers in the services sector over time. And in the blue case, when we had agglomeration, you see that one of the region kind of takes off in services, and the other regions slowly progress towards developing their services sector, but you don't see a lot of employment in services in those regions. In the red case, basically, we don't see any divergence. We don't see any difference in the sectoral composition of employment across the 3 regions. You just see one line because all the 3 lines are essentially overlapping. The other way to kind of see the same picture is just look at the variance in the composition, in the share of services sector employment across the 3 dummy regions. And in the red region, basically there is no divergence. The share of employment in services is roughly very similar across our 3 dummy regions. In the blue case, when there are agglomeration forces, because this one region is taking off, and the other regions are kind of not developing in services, you see a lot of disparity in the services sector taking off in terms of employment in the different regions. We can also test whether convergence is happening. So when we don't have agglomeration, which is the red case, we see a lot of internal convergence between regions within this hypothetical country. The beta that we estimate is sort of low. In the blue region, when we have agglomeration, you see a fall in this convergence rate as the economy evolves, as the share of workers employed in the services sector goes up. When we put in agglomeration forces, the rate of convergence falls. So that's kind of where we are at. There is progress that we need to make on both parts. We still have to do a much better job at calibrating the model to real data and so on. We haven't yet fully explored the sectoral part of the data we have. And part of the reason is so subnational data on sectors is very recent and also very patchy. So we are still thinking about on how to make progress there. Maybe we will have to do case studies, but that's one part of the data that we haven't fully explored. We plan to have more case studies like the one that we have for India, and then of course we need to do a much better job and improve the calibration exercise for this story. So with that, I'll stop and I'm happy to take questions.
Thank you, Shoumitro, for this very interesting paper. And I don't see any question yet in the chat. And is there anyone in the distinguished audience who would like to ask some questions?
I would have a question.
Yeah, please go ahead.
Can you say something about whether, in the sense, the regional distribution of economic activity in India is becoming more like, say, the American within-country distribution or less? So I understand now you talked about within India, but I mean, California is also a richer place than whatever other state you want to pick.
Yes, we should, and we can definitely see that. I haven't looked at it yet, but we can definitely do that.
Anyone else? Well, I have some question prepared under my sleeve, so I perhaps use not a question. As getting old, I can say that it's more a comment rather than a question. But the comment, I think it might be useful to understand exactly what's going on if we could see some within-country inequality measure. Like the standard deviation of the log GDP per capita across regions within countries, just to, let's say, relative to the US, just to have an idea, is the inequality, the regional inequality, is India is larger than the US? It actually connects to the previous question to some extent. It would be nice to have some, because I think the traditional idea was that within country inequality tends to be smaller than cross-country inequality. Did that change? Could have been. I absolutely have no idea.
Right.
But
so just so that I understand your comments, so one is comparing the within country inequality in India to the between country inequality between India and the US. And the other is the within country inequality in India and comparing it to the within country inequality in the US.
I rather meant the latter, because
the second one. Okay.
Yeah, I mean, we can also then compare this within country inequalities, the between country inequalities in some way. But I primarily thought about the previous one to have some idea, whether regional inequality is smaller or larger in India or some sub-Saharan African countries than the US.
So, so I know the answer for India and the US, but
okay.
for I know the answer for India, US, and China, but I will have to check it for the other countries. I can actually. Do we have 5 minutes? Can I pull out a graph?
No,
otherwise,
no, let's not do it.
Okay.
Because
So essentially, if we at the same level of development, India now has more inequality than the US.
Okay.
And the other sort of puzzle that we haven't fully rationalized is that over time, over development time, within country inequality fell in the US and China, but in India you see that to be increasing. It's going in the opposite direction.
Okay.
I mean, that would be consistent with India having a stronger service sector relative to industry.
Yes. So we haven't fully explored it, but that's.
So there's a question in the chat. Why make the assumption that agricultural growth is greater than manufacturing growth, which in turn greater than service growth? I suppose this is related to the model. Is there no evidence in India on this issue? So
earlier we were sort of starting with like with the canonical structural transformation models, but now, and I should have said this, now we actually calibrate the growth rates to the actual growth rates in these countries. So we won't have to make that assumption. Like once we properly calibrate the model, we won't have to make that assumption.
Okay.
By extension, comparing within country inequality.
I read it out. By extension, comparing within country inequality with other countries than the US. The US has a higher Gini coefficient than many other countries with similar GDP per capita.
Yes, so we should make that comparison. We should make all those comparisons and have much more evidence there. We have the data. Thank you. Yeah. Frida has the hand raised.
Oh yeah, Frida, please.
Yes, thank you. I wanted to find out about agriculture. Agriculture, when you compare agriculture and manufacturing, does it mean the manufacturing within agriculture is not covered, or how have you separated that?
So we haven't. The data comes from national accounts of various countries, and so if it's processing, I think I'm not sort of fully knowledgeable in this, but if it's processing of agricultural products, that gets classified as in manufacturing and not in agriculture.
Thanks, Doug.
Yeah, it's just, I guess it's a question, maybe thinking about calibration, but how do you unpack the sectoral story that you want to tell from, it's a funny question, but how do you unpack the sectoral changes from the spatial changes? These things are so strongly related that agricultural productivity and agricultural productivity growth are going to be, agriculture is a much bigger sector in states that start out poorer, for instance. So disentangling what's a catch-up effect from what's a sectoral effect seems like it'd be very difficult to do in the calibration.
So that's an excellent point. Yes, I think it will be hard. So right now, what we have done is we have matched the growth rates to the national growth rates and but then started off from the initial productivities of the regions. But you are right in that won't help me separate the two effects, and I will have to think more about whether it can be done and how it can be done. But that's a very, very good point. Thank you.
Okay, any more questions or comment?
Yeah, sorry, I wanted to make a question, but I don't find the raise hand button, sorry.
Okay, so, Joseph, please go ahead.
Thanks, that was super interesting. My only concern here was that you had this agglomeration in services, you don't add it in manufacturing. I guess you added manufacturing, not in services. This would move like more towards the growth of services, so towards the agglomeration would happen through manufacturing. And as the economy moves away from manufacturing to services, this would become less important. So to some extent, it seems that this is a story about agglomeration in services being more important than in manufacturing. And if so, what type of evidence would we have about it? We have heard stories from both cases.
Yeah, that's another very important point, and something that we are struggling with a little bit. So the ideal thing would have been that you have an agglomeration parameter for manufacturing and services, and then you had independent variation to estimate both separately. I don't think we have that. And in the absence, and this comes a little bit from like the urban literature, where they think that the agglomeration force in services is a little bit stronger than manufacturing. So we kind of, it's the other thing, it's not even clear whether if our story is about services, maybe we want to do away with manufacturing completely. Maybe we just have like a services and non-services sector, and then just have an agglomeration parameter for services. But I think it's definitely like a kind of a shortcoming of the paper that we cannot. It's not theoretically you can have it. It's more of a challenge. How are we going to use the data to estimate those two things?
No. Thanks.
Okay, anyone else? Okay, I have another one, if I may.
Yes, please.
It is of at least some concern that within country we don't have purchasing parity adjustment, and because that's just the common price. Although we do know that price levels vary within countries, the poorer regions, richer regions. And that does affect the estimates of beta, where you regress on the initial levels, the subsequent growth rate. So I'm just wondering whether this would be any way. I know you won't construct regional price levels, but there are data on economic intelligence units, like living cost by cities, something like that, to have just as a robustness, just to have some sense if there's scope for it. I don't know.
Yes.
I'm just saying this is a concern. I would say that we don't know.
I totally agree with you. That's something that's definitely on our checklist. So I think what we should definitely be able to do is for a bunch of countries. So definitely like India, I know that I will be able to get regional price levels to kind of bring because I have, like, for my other projects, I have that price data. So the idea would be that for a bunch of countries, we are able to show that robustness. And then there will be some countries where we won't be able to. We did think about using like real GDP data instead of just nominal GDP. I mean, if you've seen the literature coming out of India, the government messes up with real GDPs all the time. Like, they change bases to inflate growth and so on. So it wasn't very clear whether using government sort of real GDP data would be a good idea. But the price level thing, we are definitely going to do it for a bunch of countries where we are able to get that data.
Okay, then thank you for this great presentation. And now we move to our next paper on e-commerce majors, the Indian retail and the manufacturing industry. And
thank you so much.
I have two speakers indicated, Sugandha and Kanika. So who?
Yeah, thank you, Ecos. Thank you for the opportunity. Hi, everyone. Our research topic is e-commerce and the Indian retail and manufacturing sectors, and empirical analysis with a specific focus on organized sector MSMEs. Me, Kanika, Pathania, and my co-author Sugandha, Huria will be presenting the entire thing jointly. Sugandha, can you please move to the next slide? Yeah. So the fourth industrial revolution has led to the digitalization of economic activities around the globe. Digital platforms are now increasingly being utilized for the purchase and sale of goods and services, marketing, advertisement, distribution, payments, etc. Big e-commerce firms has been leaders on this front. Thus, the e-commerce sector has been playing an important role in economies around the world. So these have helped expand the market reach and the customer base of numerous sellers, while also being regarded as a convenient form of purchasing by customers. So like most countries in the world, India too has been witnessing an expansion in its e-commerce sector in the recent years. So the e-commerce in India was ranked 71 in the United Nations Conference on Trade and Development, UNCTAD, B2C Economic Commerce Index for 2020, up from 75th position that it secured in 2019. So out of the 152 countries considered, Switzerland secured the first position, and the US, which is also the India's biggest trading partner, has secured position 12. Countries such as UK, South Korea, and China that have prominent e-commerce industries are placed 5th, 18th, and 55th position respectively in the UNCTAD B2C e-commerce index. In India, factors such as the growing penetration of smartphones, cheap modes of communication, better logistics systems, digital payments, and expanding workforce and population having a positive impact or effect on the overall consumption expenditure and have contributed significantly to the growth of its e-commerce sector. Further, the sector also doesn't require any middlemen, thereby saving the cost in this manner as well. Thus, the e-commerce sector, while providing wider options and charging lower costs, may still be profitable than its offline counterparts. The COVID-19 pandemic also has acted as another catalyst for the expansion of the e-commerce sectors, not only in India, but in most countries around the world. So while digitalized firms survived and even thrived during the pandemic, a good proportion of their offline counterpart witnessed a decline in their revenue, with some offline firms even shutting down their operations. So basically, this highlights the potential gains to the Indian economy if more of it goes online. So, however, in Indian industry, specifically manufacturing, lacks the adequate digitalization, which is basically a precondition for the e-commerce industry. And more with the digitalization is lower than its international competitors such as China. So, Sugandha, can you please move to the next slide? While the benefits of the e-commerce sectors and firms going digital have been explored and accepted in the literature, recent years have witnessed a surge in the complaints against the e-commerce majors in India. The complaints have primarily been raised by the Traders Association. Traders Association is basically a group representing small and medium businesses of India on practices such as predatory pricing, deep discounting, preferential treatment for some sellers by big e-commerce players of the country. In India, Flipkart, Walmart acquired Flipkart in 2018, and Amazon together accounts for approximately 63% of the e-commerce sector. So the traders associations have claimed that such practices have abated a pool of business opportunities available for the Indians, micro, small, and medium enterprises, MSMEs, specifically the brick and mortar retailers, which have been experiencing a substantial decline in their turnover in the last few years. However, contrast this with the studies that is on the left-hand side of this slide, contrast this with the studies that claims that MSME going online and selling their product on e-commerce platforms is likely to prove beneficial to them. So a study by KPMG 2015 does point towards the positive effect of e-commerce platforms on sales, revenue, and distribution channels of Indian online MSMEs. However, the assessment has been done only qualitatively. And more importantly, the issues raised by traders associations have not been addressed adequately. A recent study by Indian Council for Research on for International Economic Relations, ICRIER 2022, highlighted that during the COVID-19 pandemic, the e-commerce platform became the mainstream channel for Indian MSME to sell their product online, providing them with a wider customer reach with a valid option. Therefore, it becomes critical to examine the impact of e-commerce major on the MSMEs in India, since on one hand, traders associations have been alleging that e-commerce majors have been indulging in the business practices that are unfavorable to them. While on the other hand, MSMEs have been expanding their online operations with the help of these big e-commerce players. It is also imperative to address that such issues, since MSMEs assume a crucially important role in the Indian economy, so majorly contributing to about 1/3 of country's GDP and nearly half of its export. So basically, so despite having gained a lot of attention since 2016 or so, there still exists a dearth of studies examining these complaints in the Indian context. So majorly, this report or this paper aims to first understand the types of complaints being raised by MSMEs against the e-commerce majors in India vis-a-vis their comparator economies. And second is to look at the rationale behind such complaints by conducting a series of empirical assessment to examine the effect of e-commerce sector in India on retail sector and the manufacturing sector with a particular focus on their MSMEs. Sugandha, can you please move to the next slide? So the broad structure and the flow of paper is as follows. So firstly, we will look at the issues that are being raised by Traders Association against the e-commerce majors in India. Within this, we'll be looking at the inter-country comparisons of issues raised against the e-commerce major. Then we will be looking at the broad literature, that what has been done in this regard. Then we will be looking at the graphical analysis of the trends with the empirical analysis to gauge the influence of the e-commerce sector on the sales and the GVC participation of the retail sector, the manufacturing sector, with a special focus on their MSMEs, followed by a summary and conclusions. So basically, in this section, an attempt has been made to understand the different type of complaints being raised against the e-commerce major. So this has been done by categorizing the existing set of complaints into two groups. The first relates to the general issues, while the second sheds light on some specific issues that have been raised by the Traders Association, specifically for the case of India. So the general issue pertains majorly to the structural weakness of the MSMEs with that of a large firm. So for instance, inadequate access to technology, lack of skills, low inventory base, etc. So such issues have been inevitable existence in any economy and not just in India. So as in every country, there is existence of both small and large firms with access to different resource bases. So if I just want to come on some explanations or some points, what do we mean actually by the general complaints that are being raised by by the MSMEs? So first is due to there's insufficiency of warehousing facilities and inventory capacity. Second, there is a problem while selecting the logistic services. Third, that MSMEs often struggle with digital payments during self-fulfillment or merchant fulfillment logistic process. Moreover, MSMEs also face high costs in the bidding process to feature their products on the first 3 pages of the e-commerce. And there are lack of transparency primarily with respect to the search ranking criteria that have been also raised as one of the issue. Now, moving to the specific issue, the specific issue mainly pertains to the business practices such as predatory pricing, deep discounting, misleading advertisement, and preferential treatment for some sellers. So the traders associations have been claiming that the business of the MSMEs are getting hampered because of such monopolistic practices adopted by the e-commerce major. There have also been complaints from the demand side, that is the consumers, on the practice of the misleading advertisement that prevents optimal decision making on their end. So, to give some examples of the specific issues, such as predatory pricing. So what is predatory pricing? It's a monopolistic practice where a dominant company sells a product below its marginal cost, aiming to eliminate the competitors from the market. So basically in India specifically, this predatory pricing is not allowed, as the, so gonna just move back to the previous slide only. Is not allowed as the minister, Piyush Goyal, Minister of Commerce and Industry, have published that e-commerce majors have no right to adopt predatory pricing. So such type of specific issue doesn't exist in India, while in the next slide, when we look at intercomparison of the countries, we will see that this is a major issue that has been raised in the international aspects. Then, if we talk about the deep discounting, deep discounts are basically the practices wherein the e-commerce platform offer heavy discount on goods and services which are sold in high quantities. Similarly, there are preferred sellers. Preferred sellers is when we give preferential treatment to certain sellers. And there is a misleading information which is majorly presenting the false details of the product or services, usually with the respect of their price, quality, and quantity. So we're gonna move to the next slide. Yeah. So to verify such complaints are whether specific only to India or its peer also are experiencing the similar issues due to rapid expansion of these e-commerce sector in the world trading platform, we identified 12 different countries, 6 developed, mainly United States, UK, Germany, Canada, European Union, and Italy, and 6 developing countries. India, China, Costa Rica, Mexico, South Korea, Vietnam, and Brazil. And we have made an attempt to perform a similar exercise of culling out the information on the type of complaint that are being raised against a major e-commerce platform. So most of these countries are selected on the basis of the presence of both the Walmart and the Amazon in their respective economies. Now, if we move to so if we talk about the comparisons, so basically amongst the complaints that are raised by Traders Association against the e-commerce major in India and in comparative economies, if you can see that predatory pricing, this column, predatory pricing, is most commonly found complaint, which indicates an illegal business practice of lowering the price to eliminate the competition. Despite allegations against the e-commerce majors of predatory pricing, the Competition Commission of India, CCI, India's antitrust body, didn't find any evidence that the e-commerce major have indulged in any form of predatory pricing in the country. However, other countries such as US, China have witnessed evidence of this practice in their respective countries. Other complaints, if you look at the other complaints, including the preferred sellers and deep discounts, were witnessed in India. Similar complaints have also been identified in US, China, and South Korea. As a difference, it was evident that the e-commerce majors in China also practiced choosing one from two, where e-commerce platforms try to influence sellers to choose their platform to sell their product instead of selecting their competitors. So such practices prove that e-commerce majors in China are deliberately strengthening their marketing position and gaining a competitive advantage. There are not many complaints raised against the e-commerce major related to potential treatment to certain sellers, deep discounting, or misleading advertisement in countries such as Costa Rica, Mexico, Germany, European Union, Vietnam, Brazil, and Canada. So here it is important to note that a lot of countries in EU fared quite well in the untagged B2C e-commerce ranking. So this somewhere implies that it may not be the boom of the e-commerce sector that is leading to the challenges faced by MSME around the world, but rather it may have something to do with the reasons such as their capacity to digitalize, structural issues such as their size, and the legal support offered to both MSMEs and the e-commerce sector of the country. So to summarize, it was observed that challenges raised by MSMEs may not directly attribute to the boom of e-commerce sector. Rather, it is a structural weakness due to which these firms are facing issues, rather related to the growth of the new age digitalization. However, a qualitative investigation like this aids in understanding the nature of the problem being raised, and we can draw some parallels, but it cannot provide an effective conclusion in terms of the actual effect of the e-commerce major on the retail MSMEs firms, or we can say the retail industry as a whole. So such effects can only be captured with the administration of an empirical exercise, which now will be followed by Sugandha. So basically, the presence of e-commerce major not only has a direct effect on the retail sector of an economy via the e-entities themselves being a part of the sector, but they are also likely to have some indirect effects on its manufacturing sector due to the presence of positive externalities and backward linkage. This is simply because e-commerce majors primarily sell manufactured goods via their platform. So this paper, now this part of the qualitative assessment will be taken up by Sugandha.
Thank you, Kanika. So just to talk about the literature that exists in this regard. So when we delve deeper into the literature, for countries like UK, US, Netherlands, some of the other developed countries, there still exists some, progressive literature on assessing the impact of e-commerce or online commerce or offline counterparts. However, when we looked at the results and tried comparing the findings, there exists certain contrasting evidence. So mixed results are there. But when you consider looking at the Indian economy, this literature is quite scanty. Only in recent years, we could figure out that there are these two studies. One is by Gotham 2017 and the other one is by Tucker and Sharma 2021, who have tried to, figure out the role of e-commerce in assessing the impact of e-commerce on export participation of firms. However, these studies also did not use any sort of panel assessment to figure out how the growth of e-commerce sector has contributed towards internationalization of Indian firms. But because e-commerce, as Kanika, pointed out in the first slide, that one of the prerequisites for any firm to actually, take advantage of this growing e-commerce sector is to be the firm should be digitally adequate, right? So we also looked at the growing literature on the impact of digitalization on Indian firms, specifically the MSME firms. So now there does exist some sort of literature. So these studies by Reddy and Sachidharan or Gopalan et al. 2022, among others, these focus on how digitalization has improved GVC performance of Indian firms. And by GVC performance, we mean both GVC intensity and also GVC entry. But the problem is that none of these studies that we could figure out specifically focus on MSME firms. Now, why are we stressing so much on MSME firms? Because the issues that Kanika has discussed against the e-commerce merger have mainly been, risen by Indian retail MSMEs. So therefore, it is important to see whether there exists any rationale behind such complaints or not. So now if you look at the studies that are, the other qualitative assessments that are there in the context of the Indian economy, ICRIER has done one of the recent attempts. But the issue was that, of course, since it was a survey study, its observations are met only for 1 year. The second issue was that only online firms, all those firms which have already, onboarded themselves on these e-commerce platforms, specifically Flipkart, were assessed during that particular time period. And the third observation is that this assessment was done during the year 2020, which of course is a very special year, right? So that is why this does not provide us with the robust evidence, or in other words, this does not provide us with a methodology to assess whether there exists any rationale behind the complaints that have been raised by the Indian retail MSMEs against the e-commerce majors. And this study is very timely. Why? Because, in the context of the Indian economy, at least our e-commerce policy is still in its draft stage. So whenever these complaints have been raised starting 2018, we have seen that a lot of press releases, a lot of press notes have been released by the government of India regarding banning flash sales or maybe banning, practices such as predatory pricing, deep discounting, etc. But still the e-commerce policy is not in its place. And therefore, it is important to see whether actually this e-commerce sector can be held responsible for the poor performance of Indian retail MSMEs or not. So basically, there are three main contributions of the paper. Of course, we looked at different reports, newspaper articles, industry bodies reports, etc., to figure out what are these issues that have been specifically raised against e-commerce players. And our assessment is not just specific to India. We have also looked at international comparative economies. The second point is that, we quantitatively now try to assess the importance of this e-commerce sector on the domestic performance of 4 different segments. The first segment is the overall Indian retail sector. Then we put a specific focus on retail MSMEs. Then we look at the impact of this growing e-commerce sector on the Indian manufacturing sector as a whole. And the fourth and the last segment is the manufacturing MSMEs. Now, the question arises is that why are we looking at manufacturing sector? So basically, if you look at the nature of the manufacturers in India, some of them are only only manufacturers. So they actually depend on the retail sector to sell the products to their end customers, right? And basically for the retail sector also, the manufacturing sector is one of the most important sector in terms of backward linkages. And therefore, instead of just looking at the impact of the Indian e-commerce sector on the retail sector, we are actually trying to assess its impact on the manufacturing sector and specifically the manufacturing MSMEs too. And lastly, we do not just constrain ourselves by domestic performance of these firms. We also look at the impact of e-commerce on the GVC intensity of these firms, because with the help of e-commerce, it is, the manufacturers are not just getting another platform to showcase their products to a wider set of audience, but at the same time, even imports and exports, these e-commerce platforms actually facilitate both imports and exports on the context of these firms as well. So coming to the data set that we have used, so we have relied on the Center for Monitoring Indian Economy's Prowess data set, which is a very big data set comprising of information about 40,000 firms belonging to the Indian organized sector. So we do not have access to, in India specifically, there is no time series data available for the unorganized sector. We do have national sample surveys, but these are not performed every year for the unorganized sector. Therefore, we are focusing specifically on the organized sector. Within this organized sector, when we used the MSME definition for the year 2006, which was adopted till 2020, we could figure out that around 34,000 firms actually belong to the MSME sector. And these firms are, belong to both manufacturing and so we could figure out data for both manufacturing and services sector firms, including the Indian retail sector. Now, how have we defined the e-commerce sector? So again, in the context of the Indian economy, there is no specific data that only talks about the performance of e-commerce, sector, or maybe tells us that, look, these are the firms that are into the e-commerce platform and this is their sales and other financial variables. We do not have access to that data. So what we have done is, based on the CMI Prowess database, we actually figured out the industry categorization of all the firms, and then we looked at the data that is specifically meant for online marketplaces. So all those firms which have been categorized as online marketplaces within the CMI Prowess database have been considered to create this variable on e-commerce or e-retail in the context of the Indian economy. So we have taken the sum total of sales coming from all these online firms, and this data has been considered starting year 1992 till 2020. Now, what are the issues as far as our definition of e-commerce sector is concerned? So if you look at the CMI Prowess, of course, you will see that a lot of big e-commerce firms and a lot of well-known, well-recognized e-commerce firms such as Amazon, Snapdeal, etc. have been categorized as online marketplaces. But, to our surprise, when we were trying to figure out the category under which Flipkart, which is the top leader in the Indian e-commerce sector. So Flipkart's share is even more than Amazon in the context of the Indian economy. It was not categorized as an online marketplace. Rather, it was categorized as a wholesale retailer in the CMI Prowess database. So we actually, culled out the data of Flipkart from the wholesale retail firm and put that into the online marketplace data in order to figure out our main variable of concern. That's the e-retail variable. The second issue with the CMI Prowess database was that it either categorizes a firm as an online marketplace or puts it into another category of an offline marketplace. So that means that none of the firms have been categorized as utilizing the hybrid mode, which is, one of the most prominent modes today. So, even the small firms are now trying to utilize both the offline and online marketplaces in order to sell their products. But again, in the context of the Indian economy, the Prowess database does not entail any information on such firms. So that means the variable that we have constructed, it is actually highly underestimated. But still, in the absence of any other database, this is the this is the only variable that we could construct in order to quantitatively assess the importance of e-commerce sector on the Indian economy. So before actually moving on to the rigorous empirical assessments, this
I'm sorry,
graph
Sugandha, you have 3 minutes left. Sorry, you have 3 minutes left.
3 minutes. Okay. Let me just
let's say 5 minutes. Okay.
Okay. Sorry. So, so we, as I said, that we have looked into two different kinds of analysis. We have tried to assess the importance of e-commerce sector in impacting the domestic performance of those four segments: retail MSMEs, manufacturing, and manufacturing MSMEs. So here the first assessment is on the basis of the domestic performance assessment only. In order to measure that variable, we have utilized information of sales of a firm. So this I is the firm variable, and T of course refers to the time period. Our main variable of concern is this interaction variable between the e-commerce sales in a year, which in turn represents the growth of the e-commerce industry as a whole, interacted with firm size. So that's how this becomes a firm specific variable, and we have controlled for a whole lot of covariates. So this is not the only set of covariates. Because of space issues, I've only put the main important covariates here. Now, as we can see here, we have two different, variables: retail without Flipkart, that is the main definition that's coming from the CMI Prowess database for online marketplaces. And then we constructed another variable by including the information on the Flipkart sales as well. So that is what is referred to as retail with Flipkart. And therefore, for all the other three segments also, we have got two different regressions. So our main finding from this analysis is that the e-commerce, the growth of the e-commerce sector in the Indian economy has actually impacted, both positively and significantly the country's overall retail sector and its overall manufacturing sector too. So that means, in other words, in the absence of this e-commerce sector, the incremental growth that these sectors have experienced, both the overall retail and the manufacturing sector, would have been lowered. And in fact, but on the other hand, in the context of MSMEs, if you observe, for the retail MSMEs as well as for the manufacturing MSMEs, even though the result is positive, but it is not significant, right? And we actually, again ran an alternative assessment wherein what we did, because we know that at least in the context of the Indian economy, one of the first e-commerce majors, that's Flipkart, that came in the year 2007, but this entire industry started growing at exponential rate only after 2014. So we performed a structural break test. We could figure out that this e-commerce sector in the Indian economy actually experienced a break during the year 2014, and we ran the same regression again, and the results were mostly similar. The only difference was that now even the manufacturing MSMEs variable turned out to be positive and significant, which means that now the manufacturing MSMEs are shown to, get advantage from this growing e-commerce sector, both positively and significantly, but the result for retail MSMEs remain the same. Now, there could be various reasons that we have already discussed, before. One could be lack of technical acumen on the part of these retail MSMEs, or maybe because in our, study, there is no difference between the online and offline firms, and therefore it is highly possible, because these beta coefficients are on average coefficients, it is highly possible that the result is positive and significant for the firms that are already on some online platform, but it is negative for those which have not yet onboarded themselves on the these online platforms. And then we move on to the analysis of e-commerce and how does it impact the GVC intensity. So how are we defining this GVC intensity? It is basically the sum of import and export in the numerator divided by total sales of a firm. So this is specifically meant for only those firms which are already into the international platform. And our main results from this slide are as follows. For both the retail, the overall retail and overall manufacturing sector, once again, we observe that the impact has been positive and significant. This time for the manufacturing MSMEs too, we could figure out that the result is both positive and significant. That means the e-commerce sector has impacted positively both the overall retail and the overall manufacturing sector. Even the manufacturing MSMEs have been benefited in terms of improving their GVC intensities. However, the retail MSMEs still are left behind. So that means that there still exists some sort of untapped potential on the part of these retail MSMEs, and that is the reason as to why they have not been able to take significant advantage of this growing online commerce. So just to conclude our slide, I would like to point out that, as I said, that India's e-commerce policy is still in its draft stage. MSMEs are very crucial for the Indian economy, and therefore when these complaints were raised from the Indian MSMEs, our government responded very quickly in terms of releasing certain press notes, in terms of, changing the FDI model, that is very important for this e-commerce majors in the context of the Indian economy. So unlike other countries like China, South Korea, India only allows FDI and marketplace model. It doesn't allow inventory based model. So this is one of the major restrictions in terms of FDI for these e-commerce players. But the issue is that now that we have realized that e-commerce indeed has been very, useful for the growth of both overall retail and overall manufacturing sector. Therefore, listening to only complaints from MSMEs should not, force the Indian government to restrict it to e-commerce practices. Rather, steps should be taken in order to ensure that these MSMEs are also able to take significant advantage of the growing online commerce. And the last point that I would like to raise is that our analysis is only specific to the production sector. But if you actually look at the, the main beneficiaries from this growing online commerce is the consumption sector, because consumers are of course acting as king here. They are getting benefited a lot because of this growing online commerce. And despite the fact that we've not included the consumption sector in analysis because of lack of data, still we could figure out the positive and significant impact that the e-commerce sector has created on the Indian overall retail and manufacturing sectors. Thank you. And we're sorry for taking more amount of time.
Yeah, thank you. So any questions or comments, please?
I have one question actually. I was just
Okay,
wondering,
please.
yeah. Actually, I was a bit lost in the how you constructed proxy for the e-commerce sales. I thought that part was pretty interesting, but I think I need more explanation about the data.
Okay. So basically the CMI Prowess database is a database of different firms and their financial variables, including the domestic performance variable and forex market variables as well. Now, the thing is that when they list these firms, they list these firms according to the National Industrial Classification, which is NIC coding that's specific to India. But if you look at the International Industrial Classification, one of the major classification is ISIC. So NIC in India actually corresponds to the industrial classification that is usually followed in the international, as far as the international standards are concerned. Now, when you go deeper into this NIC classification within the retail sector, because e-commerce is a subset of the overall retail sector, right? These are only sellers. These are not producers of goods. So e-commerce is actually a subset of the overall retail sector. So within this overall retail sector, one category is for the online marketplaces. So from the Prowess database, we extracted information on all those firms which have been categorized as online marketplaces. Then we took a sum of their sales in order to construct our e-commerce industry sales variable. So that's how we have defined this e-commerce variable in our data set. So of course, the limitation is that we are only focusing on the organized sector in India. But as far as the nature and the development of the Indian economy is concerned, the unorganized sector is very huge, right? But at least e-commerce still, since it is a new segment, more of this market is being dominated by the organized sector only. And the second limitation, as I pointed out, is that in case of Prowess, you either get access to online marketplaces or rest of the firms are categorized as offline firms. But nowadays, we see that a lot of firms are actually adopting hybrid model. They operate within their brick and mortar stores and they are also selling online, right? So these are both offline and online firms. Sorry, yeah.
Yes, so basically it's the total sales of the what you classify as the e-commerce sector. Am I correct?
Yes, e-commerce industry sales. Yeah.
Okay, thanks. That was what I need to know. Thanks.
Thank you.
Okay, so if there are no more questions, then we have a break a bit earlier, and we will be back in 80 minutes, so by 5:15. for the last paper of the workshop. Okay, so see you at 5:15. Okay, so welcome back, everyone, after the break. So the last paper of our workshop is on literate farmers of Africa, social mobility across generation. And Nicolas, the floor is yours.
So thank you very much. Let me share my screen. Okay. Thanks a lot. And let me start. So before I start, let me say that I will be in the job market this year, and this is intended to be my job market paper. So any feedback is welcome. Okay, let me jump into the motivation. And my motivation is the story of William Kamwamba. So William was born in rural Malawi by a family of illiterate farmers. At an early age, he was forced to drop out of school because his family was unable to continue financing his education. Undeterred, he continued to read and learn on his own by borrowing resources from his local school library. The knowledge he self-acquired from books helped him to develop this windmill you see over here, and that managed to provide the necessary electricity and water to his family and village during a period of famine. His construction was so remarkable that it spread via media outlets, local media outlets, to the outside world, and people were so impressed that stepped in and provided the necessary money he needed in order to continue his education. Today, William has a bachelor's degree from the prestigious college, Dartmouth College in the US, and he works as an engineer. So the story of William, yes, is an isolated case, it's exceptional, but it should not be unique. The opportunities to succeed in life, irrespective of your family background and in such socioeconomic conditions, characterize fair and equitable societies. But aside from the feeling of fairness, there is also an economic importance. Africa is a relatively young continent. Its population is expected to double within the next 30 years. If this young labor force is provided with the right incentives and the right job opportunities in order to succeed in life, then Africa has a tremendous potential for economic growth. If, on the other hand, this young labor force is deprived of job opportunities, especially those at the bottom of the income distribution, then it's very likely to bring Africa into a period of instability and tensions, as the recent history have shown. So naturally, I guess this background is somebody will ask, how do African countries fare in terms of economic opportunities, especially for those at the bottom of the income distribution? Are there any disparities across countries, across local labor markets, but also across demographic groups? Do we observe a gender gap? Do we see a rural-urban divide? Is there a religious gap? And what policies could be implemented in order to promote job opportunities? And if any existing policies are there, have they been effective? So in this paper, I tried to address all these questions. But before, let me take a step back, and before I explain how I address this question, let me tell you what the literature have done so far. So how do we measure opportunities as economists? So the literature has focused mainly in advanced countries. And here I'm referring to the famous studies by Jaedo co-authors, but also Korak, whether they have good tax administrative records. By linking parents to their children in these countries, they assess whether children born from parents at the bottom of the income distribution manage to surpass their parents in terms of income. So in countries where these children, a certain fraction of these children manage to do better than their parents in terms of labor earnings, are considered as mobile countries. Whether it's in societies, where the children are expected to end up at the bottom of the income distribution as their parents, are considered as less mobile societies. In developing countries, we don't have this super good data or large amount of administrative records. So it's not possible to conduct such exercises. Instead, recently, development economies, they use education as a proxy of income. We know from ministerial regressions that education is highly correlated with income. So if children are doing better than their parents in terms of education and attainment, we expect them to do better also in terms of income. So here I'm citing the famous study by Elisa and econometric and co-authors where they found that in Africa, almost 40% of the children born from parents that are completely literate, they managed to finish at least primary school. Obviously, they did a study across a wide set of countries, and they find there is huge variation across African countries, but also even within countries. Similarly, Asher did a similar exercise and co-authors for India. Although it's very formative studies, there is a limitation. The limitation is they don't capture distortions in the labor market. What do I mean by this? It's very likely if I'm born in rural Malawi that I managed to complete primary school, but because of frictions in the labor market, I ended up working next to my father as a farmer, although I'm illiterate. Have I progressed? Surely not. So where this paper comes from and what is the main contribution is to use occupation as a proxy of social studies. And in particular, what I do, I study intergenerational mobility in occupational attainment in Africa. And what in particular I exercise and I do is I found what fraction of children born from low-skilled parents manage to have a medium or high-skilled job. And I do these statistics or these metrics across a wide set of countries, 27 in particular, but across also demographic groups. I separate males, females, those that live in urban regions or in rural regions, but also across religion and ethnic groups. So this is a descriptive part that I have the data. In the second part, I try to understand what factors shape occupational mobility rates, especially upward mobility rate. So again, the literature here has focused in developed countries, where we know that investment in human capital, child formation early, she has a paper by Heckman and co-authors, or progressive taxation, or even recently the network channel by Chatterjee affect intergenerational mobility rates. Nonetheless, in developing countries, they do not necessarily, these factors translate in developing countries. So I do a very simple multivariate regression analysis in order to understand what observable individual and family characteristics could explain partially this occupational mobility rates that I found. And in particular, I focus on education and attainment that I have in bold because I believe is a stronger predictor of upward occupational mobility. But also examine the fertility rates, family stability status, but also access to basic infrastructure. On the country level, I wanted to see why countries differ between each other, and I use another set of variables that I download from World Bank. Is it because they are more urbanized? Is it because they have more healthier populations? Is it the school infrastructure? And this is what these factors I do in a correlation set in this paper. In the third part, given that I found that, as I said before, education and attainment is a stronger predictor of higher occupational status, I want to evaluate the causal effect on education on intergenerational mobility rates. We all know education is an endogenous variable, so I need an instrument in order to find the causal effect. And the instrument is the reform free primary education when 5 African countries abolished the fee. So if I use the reform as an event study in these 5 African countries and the spatial variation, so in the promises, the differences they have in school completion rates, I may be able to identify the causal effect of it. I'm able to identify the causal effect on education on upward mobility rates. In a nutshell, what I find that in the descriptive part, 32% of the children born from low-skilled parents, so parents that traditionally are occupied in farming or in elementary occupation or household activities, 30% of their children manage to have a medium or high-skilled job, such as blue-collar or white-collar jobs. Obviously, this aggregate statistic must substantial variation across countries, but also within countries, across birth cohorts, and different demographic groups. For instance, I find a wide gender gap. There is 11% difference between men and women, but also a 30% difference if you are born in urban or if you live in a rural region in Africa. In terms of the correlate, as I already stressed out, I find that education, and in particular finishing primary school, is a stronger predictor in order to get a blue collar or a white collar job. But also other proxies like fertility rates, family stability, and access to basic infrastructure, such as the household has access to electricity and water, are also predictors of occupational mobility rates and can be examined deeper with structural models. In terms of the countries, I find that more urbanized countries, as expected, with better labor markets, healthier populations, but also school quality, have higher rates of upward mobility compared to other countries. In the causal, in the third part of this paper, I find that abolishing fees in the 5 countries in my sample, I find that by abolishing fees has increased educational attainment in 4 out of 5 countries in my sample. In the reduced form evidence, I also find that abolishing fees has increased occupational mobilities in 3 of the countries of the sample, but decreased occupational mobility in 2. And if I take these 2 results together in the 2-stage least square regression, I found that education has an effect on upward mobility in 3 of the countries and an adverse effect in 2 of the countries in my sample. Why there is this heterogeneous effect? Why education in some countries boosts mobility and in others has an adverse effect? I argue this is because of another confounding factor, that is differential school quality. And this is a paper that this is a part of the paper that I'm still working on it. Let me briefly describe the data. So I retrieve all my data from IPUM's international database. So in particular, I extract 63 censuses from the data sets that I have information in education, occupation, both the parent and the children. This includes 27 African countries that I list in the second bullet here. So all the censuses are conducted between the 70 and 2016. In total, I have 7.7 million children, age 15 or 25, African children, that live with at least one parent that is still working in the labor market, meaning is less than 65. Okay, methodology. How do I develop the intergenerational mobility indicators, the key statistics? So the first task is to rank occupations. How do I rank occupations? I think it's simply about the education intensity required in order to exercise each occupation. So I take the years of schooling of each individual, here as labeled by EI, and I weighted accordingly to the individual sample in the weight. And what do I find when I perform this exercise for each 1-digit occupational category, ISCO 08, that is the standard international classification? I find that, as is expected, white-collar jobs, so jobs that are traditionally considered white-collar, such as professionals or technicians, have the highest years of schooling, something expected. On the other hand, agricultural or other elementary occupations that consider low skill are also ranked last. So they have, on average, between 2.5 to 4 years of formal schooling. And in between, I have those occupations like manufacturing occupations are considered blue-collar jobs, such as plant and machinery operations, craft-related workers. So in the second term, I want to understand how these 3 categories are transmitted across generations, from parents to children. And in order to do that, I do a 4x4 transition matrix. Let me walk you through the chart. So on the horizontal axis, I have the fraction of parents in each occupation. So for instance, the bar width here reflects that in Africa, 30% of the parents are occupied as farmers. Another 40% are stay at home and do housework. And 98% of this category are mothers. Then the 2 other smaller categories are blue-collar jobs and white-collar jobs. On the vertical axis, I have the fraction of children that they enter each category. For instance, if we take the first column, we know that 30% of the parents are occupied in agriculture, but also 75% of their children would ended up becoming also farmers. So already from this chart, we can see a strong occupational inheritance in Africa. If we move, for instance, in the second column, we see that, yes, only 25 to 30% of the children ended up to become house workers, but an additionally 25% ended up being as farmers. That is equally low skill, low paid job. So in total, even in the second category, more than 50% of the children are becoming a low skill professionals, conditional that their parents are also low skill. The picture is reverted for blue collar. We can see that blue collar parents manage to have the majority of their children, or on average, their children becoming either blue collars or white collars. And for white collars, the strongest category, the bigger category are white collar jobs. So overall, we can conclude, yes, there is heterogeneity also across countries that I don't show here, but you can find the paper, but there is a strong occupational inheritance in Africa. Given that the relevant dimension is to escape from low skill professions and go to medium to high skill, I reduce the sparseness and I further group the two categories, the farmers and housework categories together, and the blue collars and white collars together. I label those as high skill and those are low skill professions. And what do? I derive two simple binary indicators. The first that I say occupational NAP takes a value of 1 if the child born from low skilled parents have a higher skilled profession. In a sense, if your parents are farmers or working elementary jobs, and you manage to become a blue collar, white collar, you take a value of 1. Otherwise, you take a value of 0. The reverse is downward mobility. If your parents are blue collars or white collars, and you have a lower skill job, then you take a value of 1. Otherwise, it's 0. Then, in order to match the statistics in a comparative setting across African countries, I ran separately for each country the following set of regressions. So the binary indicator on a constant, and then on a set of fixed effects. The birth cohort of the parents' fixed effects, the decade set to fixed effects, and the birth year of the young fixed effects. So I collect the alpha 1 for each country, and I interpret it as a probability of an upward mobility after netting birth cohort and decade fixed effects. Similarly, I do exactly the same regression for occupation, from downward occupation, and I collect alpha 2. So if I do it for every country, I have 27 alpha 1 and 27 alpha 2. And I can add them in a table in a comparative perspective. So what do I have here? I have if you focus on the column 3, I have all the alpha 1s. And in the column 8, I have all the alpha 2s, but are sorted according to from the highest to the lowest based on column 3. For instance, here South Africa ranks the top in terms of an upward mobility because 70% of the children born from low skilled parents manage to have a blue collar or white collar occupation after I net all these fixed effects. Last is Guinea, where only 6% of the children manage to have an upward mobility, conditional that parents are low skill. The unweighted average across African countries is 32%. That is translated that in Africa, as I mentioned in the introduction, 32% of the children on average manage to have a better occupation, conditional that their parents are low skill. I did the similar analysis first for males and for females in order to understand if there is a gender gap. And if is conspicuous in most of the countries, but also on average, you can see that the weighted average points out to 11 percentage point gap between males and females. Urban-urban divide, as expected, is huge. So if you are born in an urban region, 60% probability to move up. If you're born in a rural, it's only 25%. The reverse statistics can be found for downward mobility. I also have in the paper several statistics for demographic groups, such as if you are Christian versus Muslims and other ethnic groups, but in the interest of time, I skip it from this presentation. Now, the richness of my data sets allow me to also study the heterogeneities within the country. So Ghana here ranks something in the middle. So 27% of the children manage to have an upward mobility. So it's 13. Nonetheless, if I do the analysis within provinces, I find that yes, on average is there, but there is a clear urban, north-south divide. You can see in the south that is color with a darker color that in these regions there is much higher probability of upward mobility, whereas in some northern regions this is close to 0. Similarly for Kenya, but any other country in my sample. Okay, so this is also the descriptive part that is very interesting, but somebody will ask, okay, what explains the differences, or what can be done in order to boost mobility rates in those regions that are very low? So first we have to understand what drives these mobility rates. In order to do that, I first resort to a very simple analysis, multivariate regressions of the binary indicator that I have, the upward occupational mobility and the downward occupational mobility on a set of characteristics, observable characteristics. Individual, household, parents, parent status, also fertility rates, and whatever other individuals live with the family. So obviously there are many variables that are missing and they can be very reserved causalities. So I consider this regression of correlates. Nevertheless, it can point out already into what is the most significant factor. And in particular, to exemplify that is education the most important, I ran 2 sets of regressions. One where
your time is run out, so you need to conclude.
Oh, okay.
20 minutes.
I need to conclude in how many minutes?
Okay, you have 2 more minutes.
Okay, so let's say that education was the strongest predictor I found so far. And I want to do a causal exercise. So as I said, I use instrument the reform. So there was an event study that was reformed. Those that affected after the reform had, so those that are born after the reform are treated, and those before the reform have not been treated. I use also a second level of variation, meaning whether the school completion rates, the spatial differences in school completion rates, in order to separate cohort effects from causal effect of education. And what do I find in 30 seconds? I show my results is if you focus on the table here, I find that in 3 countries, Malawi, Mauritius, and Botswana, finishing at least primary school have a strong probability of having an upward mobility, but in other 2 countries like Tanzania and Ghana, these have a very negative effect. And if I use different variables for education, such as year of schooling or a scale of education attainment, it does not change the overall picture. So in terms of, I have to conclude, I will say that I mapped provide a new set of statistics in terms of intergenerational mobility and occupation attainment in Africa. I find that varies substantially across countries and regions. I believe, and the regressions have shown both the correlational sense, but also the causal sense, that educational attainment, meaning access to primary schooling, is the strongest correlate of international occupational mobility. But policies to improve universal access to education were only partially successful, meaning in 3 out of 5 countries. Why is that? And this is the last section of the paper, where I developed an OG model with differential school quality, meaning by pupil-teacher ratio, in order to show that in countries where you increase access to education, but you hire also more teachers, you have better educational outcomes, whether it's in countries where you just abolish fees, but you didn't increase the number of teachers, then you overcrowd the class size, and you have an adverse effect in occupational outcomes. Thank you very much. I'm sorry for taking longer.
Okay, thank you very much. It was very interesting. Questions, comments?
I have a data question, perhaps. I was surprised to see that the fraction of house workers that you record is so large. And you mentioned that those were mostly women, even though sort of a general theme seems to be that women are primarily perform the majority of labor in agriculture. So I understand you lumped those together later, but perhaps it's worth going into a bit more detail in the definitions here.
So yes, so in terms of cleaning, how do I have the data? So either you have an occupation, okay, or either you are not employed. If you are not part of the labor force, because usually women, that's what the case you have, I try to understand why they are not employed. And I found that they are not employed because they claim that they do housework. So these are considered the houseworkers. And this is the vast majority of women. And on the other hand, the other biggest category was farmers, that is predominantly exercised by male workers. What you have to think about also here is like I have both parents. And when I say parents, it cannot be, it's not only, I don't limit my analysis only on father and mother, but I have all the individuals that live in the household. For instance, you may see in Africa that, and that's the case according to the census data, that you have the man has multiple wives, or in other cases, you have also other family members living with you, like the sister or the grandparents, etc. So I consider in a broader sense all of them as parents because they can also contribute to the generational mobility, and I take the average. For instance, if this house has 2 women and 1 man of the older generation, I take the average of them. And if the 2 women are working as housework and the man is working as farmers, given that this is predominantly a category, they will all be assigned into this category as an average. If it's half and half, for instance, then it will show us 2 separate categories in the bus, however. But this is kind of a definition. Was it clear? Or? Hello?
Yeah, I think it was clear. So we have a question from the chat. Beside education, what other variables were significant? Consider analysis of polygamous families. I'm not entirely sure.
So that's what I said before. So if you live, so it doesn't have to be a biological child. So if someone is married to multiple wives, they are also considered as mother. I take the average of them as of the average education of them, and it will lie in one of these categories. Now I have in the regression analysis, I have extended family members, as I didn't have the time to go through it, but you can see here. So the number of other family members of the older generation that they live. And you can see that, yes, the more the family members they live in the household, you have a negative, small but negative effect. And you can think of many directions. Either you have to take care of them, or they need consumption, and not all the resources are spread to the child, are spread equal to the children in the family, but some of the older members take. Yeah, and in terms of other variables, I also consider access to basic infrastructure that I also find it important, such as electricity or pipe water. So if you have access to, if you don't have access to electricity, then you have 10% of lower probability of an upward mobility in a correlation analysis, but also numbers of fertility, the number of children living in the household. And here I also have the Christian dummy that says that if your religion is Christian, relatively to be a Muslim, you have higher chances of upward mobility.
Okay, so after Frida's question, there is a question from Joe Gaboski. Are you able to examine ranking occupations by income rather than education? If so, does this matter for the conclusion of the special role for education?
Unfortunately, I don't have, and that's what my motivation, there are no data on income. And here also we point about census data, so it's not a longitudinal data set. And even if I observe them, there is a problem of measurement error. I do observe for one country, that is Mauritius, a very good data set, but I don't think it's representative for the other 27 countries.
Mm-hmm. Okay, so any more questions?
Seems like there's an assumption that the mapping of education of occupations into skill categories and therefore education into skill categories, you're assuming that's constant through time. And I wonder if that might not be shifting as these economies change in structure and so forth. Have you thought about that at all?
Yeah, this is a very good, exactly. This is a very good point, and that's something I plan to do in order to see how this change over time. And this I can do, and definitely would be on my checklist. Thank you very much. And indeed, education has increased. We know that education has increased since the 60s. So it's expected also that might be a change. So I would check.
Okay.
And is there an issue that you're focusing on youngish people who are still living in the households with their parents?
So this is a very good point. And there is, particularly, I want to focus on this group in order to avoid cohabitation bias. So the younger the child is, the younger the likelihood that is not living with the parents, and then maybe create a selection problems, given that I will not observe these people. So I only focus on age 15 or 25, that is at least 70% of the children across countries, they live with their parents. So I'm able to not have to mitigate this cohabitation bias in a sense. Now, I didn't have time to measure, but it's very important. Somebody will claim, okay, somebody that's still 15 or 16 may have not finished schooling, and then you only the occupation that you only observe is those of the farmers. What I claim here is like, and you can see in Africa, is like very few people manage to go secondary and even tertiary education. And according to my analysis, these people ended up in blue collar or white collar jobs. So these I consider them as high skill individuals. So that they complete school, secondary or tertiary school, and they're high skill individuals.
Okay.
I hope this answers the question.
Any other questions? Comments? Okay, so if there are no questions or comments, then this concludes today's proceedings, concludes the workshop, the Theme Zero 2022 workshop. I think we had a great afternoon with interesting papers from technology adoption to unequal convergence and social mobilities. These are all important subjects and issues for STEG. And I thank for the presenters, the commitment and devotion to the cause of STEG. And I hope to see each other to the other upcoming workshops.
Akos, can I quickly say thank you?
Yes, yes,
well?
Joe, please do.
I thank all the speakers as well, but also to thank Akos and Heitzen for their for putting this together, and Mandy, I guess it's Mandy, am I right, at CEPR for running the behind-the-scenes logistics, and stay involved with STEG. Thank you very much.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.